Hello and good morning to all of you. Ladies and gentlemen, we are going through our online training on LNG business strategies. We have already finished 3 days of our online training course. This is the fourth day of our training. And in today's training, we would be covering the topics on LNG receiving terminals, techno-economic analysis of virtual gas pipelines, gas supply and distribution, and regulation and policies in gas sector. Another information to all the participants that we have uploaded the updated agenda of our online training on our this software. Plus, we have also emailed all the participants the updated agenda on which we have made slight changes in today's session. And secondly, today's session will take a little bit more time compared to the earlier days training. So without further delay, I would just briefly inform you about the first presentation. The first presentation is on LNG receiving terminals. The content is on development of land-based /FSRU RLNG tolling regasification contracts, RLNG contracts with aggregators, consumers, marketing companies, virtual or small-scale LNG. The presentation will be given by Mr. R.K. Garg. I'll just briefly introduce him. Mr. R.K. Garg, a postgraduate in Commerce and member of the Institute of Chartered Accountants of India and Institute of Company Secretaries of India, possesses a rich experience of around 4 decades in areas of finance, commercial, legal, and compliance. He has deep understanding of national, international gas and LNG market. So with this, I would request Mr. R.K. Garg to start his presentation. Over to you, sir.
Good morning, sir. A very good morning to all of you, and it's a pleasure to be joining again today for this presentation. Just a minute. I'm not able to see my full screen. Can someone help me? Because I'm just still having the cam.
There is a cup. There is a cup-shaped icon. If you can press that.
Oh yeah, that. Thank you. Thank you very much. Today's presentation is basically on LNG terminal, and this is very, very important basically for the purpose that we all SAARC member countries are already importing LNG terminal, and some are planning to import in near future or use LNG in their energy basket. So this session is going to be based on few things. One is that, as Mr. Ehsan has mentioned, that it will be considering the land-based terminal, floating storage unit, comparison of these, which one is better, which one is useful, which has good techno-economics, or which one is best in what situation. And we will also discuss the tolling arrangement or merchant arrangement of these LNG terminal. And we will also take into account what are the major factors have to be considered before planning for putting an LNG terminal. And also we will also discuss the major terms that if you are going for a tolling arrangement, that what kind of terms and conditions generally is followed by the regasifier or a terminal owner. And at the end, I will finish with some slides on small scale LNG, but will not take much time on that because there is going to be a presentation by Dr. Nawaz Ahmed. Thank you very much. This particular slide which you are seeing on the screen is of an existing Dahej LNG terminal of Petronet LNG Limited. It is a land-based terminal. You will see in the background of 6 storage tanks. And this particular picture was sent by the plant manager to me a few days back, and I was tempted to put on this in the first slide. This is one of the largest operating LNG terminal and having very all kinds of facility that you look for a land-based terminal. This terminal having the 2 LNG jetties. This one is this, another one is this side. It's a 2.5 kilometer trestle, and it connects to the land. And this is a currently 17.5 million ton capacity terminal, which started sometime in 2004 with 5 million ton and expanded over a period of time. This LNG terminal has already unloaded around 2,850 LNG shipload material so far from 2004 to date. And its versatility is like this: it can take any kind of LNG ships, even up to the Q max size, which is a Qatar max of 260,000 cubic meter, and it has already unloaded few cargoes of that Q max size vessel. This is used for different kind of models. It has a merchant model where LNG is purchased by Petronet LNG and then sold to the off-takers on a long-term basis. It also used as a tolling model where major quantity around 8 to 9 million ton is getting tolled by the users, different users, multiple users, and also being used for spot LNG and buying and selling. So why I have told this about this terminal is basically to give a glimpse of a land-based terminal when we'll be discussing in detail of land-based versus FSRU, and I think that would be important. And currently, the send out from this terminal is over 70 million standard cubic meter of gas every day, and it is a 12-month operating terminal. It works on day and night unloading and facilities at this terminal. So it's a very versatile. And so what agenda I have told you that these kind of things that I'm going to present today, and you will see in other slides. Yes, this LNG value chain, this one is an important part of the LNG value chain that today we are going to discuss about the onshore or land-based terminal and floating storage and regas unit. Why this slide is basically important, that all business activity of LNG supply and regasified and end user this is also very, very important point. The reason is that entire money which comes from the end users, and then it flows back up to the last chain. So operation of this terminal and construction operation of this terminal and utilization of terminal is very, very important for every party who is involved in this chain. This slide you have seen earlier also. Currently globally that we have 850 million ton of LNG regas capacity, and around 150 million ton is already under construction. So total will be having 1,000 million ton of capacity worldwide, and it is the users are increasing and terminals countries are increasing. We heard about more than 42 countries, those where the LNG terminals are already in place. One thing I think is important to understand this, I think this question was raised earlier also, that utilization rate of a regas terminal is what is optimum. If you see this particular slide, especially those countries who have been operating this LNG terminal for a quite long time. So like in Japan, we are having 210 million ton of capacity, but the utilization is 35%, and South Korea 136 million ton utilizing 30%. The reason probably could be that because they are having a seasonal requirement, and especially winter, their demand increases and they need more gas, and plus they need more flexibility in their operation. So that is why the utilization of 35% or 30% is there in the terminals in Japan and Korea. Another thing, important feature in this, you will see the United States, because this total 850 million ton, around 50 million ton capacity is in the US, which is not under use, only 5% is used. The reason very clearly mentioned yesterday, that because of they have now gone to liquefaction instead of regasification, because there is no requirement for regasification in the United States. Other countries, especially new countries, those who have come in this LNG regas business, like China, 80 million, 83% utilization. India, 39 million ton capacity, 40 million ton, 65% utilization. And if you see the Bangladesh, it is 59%. Similarly, in Pakistan, it's 73%. So it depends upon country to country and requirement, and plus how much facility is created. Because if the demand is more and you have limited regas terminal, the definitely utilization is going to be more. as the business will grow, more and more LNG terminal would be in place, then we will see maybe a little downward trend of the utilization. Another important factor is it is not only the utilization of the regas terminal. Sometimes regas terminals are built for the purpose of marketing, because whenever you have availability of LNG at a right price, you can import the LNG and maybe used as a storage and then supply later. So these are various kind of business models are being used even for regas terminal. The amount required for building the regas terminal is comparatively very low as compared to the liquefaction facilities. Liquefaction facilities and regas terminal, say if there is $10 billion of investment of a liquefaction facility here, the investment that you will see is much low. But the activities of the regas terminal are very important. So before going into building any regas terminal of any organization or any country, I think some important factors have to be kept in view. First, one have to assess the market assessment and the demand of the gas, and what is the possibility of its utilization. Because once we have, and plus, along with that assessment, one more thing I think it is very important that one must look for and anchor customers who would be using this LNG terminal. Anchor mean, is there any power plant? Is there any fertilizer plant? Or maybe refinery, maybe petrochemical complex, or any of this major demand center? Because if we have around 40, 50, 60% of a utilization which is very close, or they are ready to use the gas from the terminal, that the life become easy. So in any case, full assessment of the demand is to be made, and then think of going for a regas terminal is to be placed. Another important factor, the decision have to be is taken is whether I am going to be having onshore land-based terminal or it is going to be floating system. Floating means floating storage and regasification unit. It would be it is going to be on the floating ship, or I'm going to be, but there is another system I think is nowadays is being seen. It is an Fsru, which is a floating storage unit, and regasification is on land. So all these systems are technologies is quite prevalent now. So initially, earlier only land-based terminals were being constructed, but during the last 1 decade, it is seen that the FSRUs are increasing, and especially in the demand center where immediate requirement of FSRU. We will discuss this in detail as we go through the presentation. Another important factor is the port selection, where we are going to install this terminal, or where closer to the port where the FSRU is going to be stationed. So marine conditions, whether it is a port which is having a good draft, which is required for an LNG ship to take berth. Is it a capital dredging is required? How much capital dredging is needed? Whether it would need the operational time also, it needs a dredging requirement, continuous basis, or it is intermediate requirement, because it adds to the cost of everything and also the operation of the LNG terminal. Whether it is an existing port, and if there is an existing port, it means it is already having other port activities closer to that, and there may be a certain infrastructure which is already available. Like if the breakwater is required, whether the breakwater is already built in, and you have other requirement of the for the ship to take the berth. So if it is not, then one have to assess the full marine conditions and go into detail the requirement, what is required for an LNG terminal. Site selection and the land availability is also important, because the land, in case of a land-based terminal, the requirement of land is more as compared to an FSRU. And the site is also important, because whether is we have the closer by, is there any village or any habitat is there, and whether it is going to be impacted with the LNG terminal coming close by. So detailed environment impact assessment study needs to be carried out, and it is required by the regulations and laws of most of the all countries, and an approval for the from the environment point is to be taken about that LNG facilities. Detailed technical and financial feasibility of the full project is required to be carried out. Technical in the sense that what kind of a technology that you are going to use it, especially for a regas terminal, whether it is going to be based on for regas it's going to be ambient air, or you are going to use the seawater. I think we will discuss in detail that what kind of a technology, what kind of a total construction the equipments are required, what kind of EPC contractor that you are going to be in place, and all kinds of gamut of the technical assessment is to be carried out. And similarly, the financial feasibility based on the demand assessment, how much cost is required, and whether the utilization is going to be how much percentage, and whether is it feasible ultimately the project to be taken care in near future. Important aspect of any LNG regas terminal is the commitment of its use, because if we build a terminal and there are no user of the terminal, so the investment whatever has been made and what are the commitments upstream are there, then it's become a very big challenge and problem for an LNG regas terminal. So whether the commitment is either 100% or 80% or 70%, or even lower than that, it depends upon the appetite of that terminal's viability and how much regasification charge is going to be charged from the end user and their ability to pay. So on as a thumb rule, generally it is considered if the offtake from LNG terminal is 70 to 80%, probably that it is good enough to start with. Pipeline connectivity is most important, because once an LNG terminal has been say commissioned and your gas starts coming, LNG starts coming at the terminal, and if the pipeline is delayed, then your activity can't move from the LNG terminal. And pipeline connectivity, not only connectivity but of a sufficient capacity, depends upon the how much gas is required to be moved from the plant so that it can reach to the customer. So pipeline connectivity, I think from the point of view commitment of offtake, pipeline connectivity, and also the selection and financial feasibility of a terminal, these things are important. Then only the owner of a terminal or those who are going to provide funding for the terminals they would be comfortable. And then after that, we should be looking for financing of this terminal. Construction of a terminal again depends upon what methodology that we are going to use, whether it's going to be EPC or it is to be on contract to contract basis. But generally it is preferred by the other chain partner, LNG chain partner, that should be done EPC, so that there is a time specific and within the budget that activity can be completed within time. So one have to manage this construction so that entire chain, because everybody is working on their activity, ship is getting built or liquefaction facility is getting built, and your terminal is also required to be constructed within that time and within that budget, because the budget, if it overshoot, again it impacts on the viability of a facility, and because your regas charge, you can't increase it whatever you have already committed with your off-takers who are going to be using this terminal. After the terminal is complete, then activity related to this operation, whether it is to be operated by an internal team which is going to be of a company who has developed this terminal, or you are going to appoint some operator for operating this facility, and plus their experience and their technical knowledge, and plus dealing with this cryogenic material. Everything I think is to be placed. This have to continue, training of this personnel have to continue along with when the construction of a terminals is going on, and regularly the terminal need to be maintained properly so that there is no hiccups during this operation. So these are the important factors have to be kept in view while deciding of going ahead with this terminal construction of an LNG terminal. This is one view of a LNG terminal under construction, more or less ready in one of the place in India. I think it is on the east coast of India. Why I'm showing this picture is because I wanted to get you just a bird view of what land-based terminal generally has. If you see these facilities on the seaside, these are the marine structure. You will find this is we call a breasting dolphin. This where the ship comes and take berth here. These are the mooring dolphin. This helps in having the ship to be tied with the shore. This one. These are the unloading arms. These unloading arms then attached to the ship when ship comes for unloading the LNG from the ship. This is the platform where all this structure is created. This is the jetty trestle. This is a jetty. This is trestle, and on this trestle there are pipelines, which is the cryogenic LNG material travel from this pipeline and goes up to the storage tanks. And also from storage tanks, there are certain vapor return pipeline. Vapor return pipeline also here, and vapors return pipelines are required basically to give vapor return to the ship when the LNG is unloading, because the ship is basically a compartment where everything is closed, so that there is no vacuum is created in between. So vapor return, which is basically a gas, goes back to the ship and filled in. I think this is important to understand, because for the measurement of LNG, how much LNG has been unloaded and how much vapor has gone back. So there have to be a credit of the vapor return when it goes back to the ship to be taken care of. This is the control room of a marine side activity. These are two storage tanks. These are of a size maybe 180,000 cubic meter, and the full containment tanks, and equivalent to a football ground of this size. And from that LNG, then it's travel and with the low pressure pumps, then it goes to the regasification unit. And from there, the regasification unit, it is I think it is the air fans, and they are using ambient air, and that is why the requirement of land is quite big. And once the gas is regasified, then it goes through the pipeline. There are utilities, because we need an oxygen, nitrogen, and other firefighting activities, facilities to be created. And these are the places where the tugboats, when they bring the ship, they have to take the berth here. This is what a dredging activity is going on. So the important part of an LNG terminal is a port side, so marine side activity, storage tank, and third is the other rest, the regasification terminal and utilities. So this is the typical flow chart you had seen in different form in earlier presentation. As now you would appreciate that when the LNG ships comes here, then through unloading arms, the LNG is unloaded in the storage tank, and from the storage tanks, then it goes through low pressure pump and for vaporizer. And vaporizer, here the water for heat exchange has been used in this diagram, but you can use the ambient air. When you use the ambient air, then there are some shell and tube vaporizer. Generally, we say that these are used for STVs, and these are in use at the Dahej as well as our Kochi terminal in India, and also other terminals, because it depends upon the condition of a site. If we have the condition where the humid and warm conditions, probably, and if the land is available, then this ambient air vaporizers are good. Whereas in places where there's a cold condition and ambient air or the temperature remains very cool, then probably it has to be a different kind of mode, could be water for heat exchanger or any other mode is to be taken. These are the other activity where BOG generated, it goes back, it comes back, and through compression that it goes for the mixturization. Another is FSRU technology, where currently 43 FSRU at the end of 2020 are in place, and having a capacity of storage capacity of 6.4 million cubic meter, and this activity FSRUs are increasing day by day, and especially the countries where the requirement is immediate and they can't wait more. This is becoming more and more better option nowadays. Especially like in Bangladesh and Pakistan, we have that FSRU terminals in place. Though in India, so far, all of the operating terminals are land-based, but there are projects, and one recently commissioned FSRU project is also there as of now. So we'll discuss in detail what are the FSRU component. If you see one typical FSRU, if it is connected to the shore, the same kind of facility that is required, the ship to be in place, but this is an FSRU. This is a floating unit, a floating FSRU unit. You will see these are the regasification plant is stationed on the FSRU. Storage tanks is basically a ship. Unloading house is there. When the one ship comes, then it is connected to the ship and LNG is unloaded on the ship. And virtually it is a ship to ship transfer is happening, and then from there the gas is exported to the consumer. So actually there is no activity on the land except that pipeline connectivity, and plus the onshore these marine site facilities are created. There are projects where FSRU is not onshore, but it is on somewhere in the sea, maybe 10 kilometer, 15 kilometer away from the sea. And then there are technologies available where FSRU is stationed on the sea, and the underground natural gas pipeline, then it is then taken for transmitting the gas to the land. Both technologies are present, but depends upon the marine condition, whether it is feasible to put this FSRU there or put on the onshore. So both are relevant nowadays. Few things have to be considered while going for an FSRU or a land-based terminal. That what is the schedule of when I need a CAPEX, how much CAPEX is required, whether I need a low CAPEX activity, how much OPEX would be there in case of FSRU and a land-based terminal, flexibility I needed, whether it is a peak shaving terminal, what are the content. I think these important factors we will discuss. This is some slide, I have taken it from the web. It is of some study done by one of the company, and for a comparison of a 3 million ton facility of a land-based FSRU. So for a land-based, they are indicating the indicative costs are coming for a jetty including pipeline. It was considered as the same because it is a ship have to take berth, around $60 million. Unloading line here it is required for a LNG terminal. For a tank, it is around 85 million. They have considered only one tank. For a 3 million ton facility. If it is a more, then you need probably 2 tanks of that capacity. In FSRU, because the tank is on ship, there is no investment required. FSRU vessel cost have been considered around $250 million. It is a new FSRU. It's considered. Terminal owner has an option. Instead of putting that cost, they can hire the FSRU, and the FSRU owner can provide the services with a fee. All other process equipments, as I mentioned, that are required to be placed on the LNG terminal. The costing utility is that, and for onshore infrastructure, a minimum expenditure that is considered for that facility or that site is around 30 million, and other charges are like this. So comparatively, it was indicated that around 560 million versus $360 million is the capex required for a 3 million ton facility if it is a land-based on FSRU. So numbers could be different, but one thing is sure, that the cost of an FSRU is lower as compared to the land-based LNG terminal. We will see whether which is good, which is not bad. Before that, I think the operating cost, though here indicating 20 to 40,000, since it is a 3 million ton. So in my view, the operating cost would be much lower in case of a land-based terminal as compared to FSRU. The reason being that here the power requirement of FSRU power cost is more as compared to the LNG terminal. And so again, one have to see the assessment. OPEX Generally on the land-based terminals are low and FSRU are high. Time taken for an FSRU and land-based terminal is an important factor that generally decided. Land-based terminal takes a longer time. It's around 36 months after award of an EPC contract. The reason why award of EPC contract is because the LNG tank itself, completion of the construction takes 36 months. And other activity can be done along with that. So 36 to 40 months is required for LNG terminal after decision is taken and award has happened. There's an FSRU, it takes around 24 to 36 months, depends upon whether you are getting yourself ship built or you are hiring, and how much facilities are required to be created on site and what are the conditions are to be in place on the FSRU. So time for the terminal to be ready is less in case of an FSRU. So if you compare the land-based versus FSRU, as per the industry standard, FSRU is an emerging technology, but increasingly it is accepted, whereas the land-based is an industry standard. So out of this 850 million ton of existing capacity, if you really go in detail, you will find maybe 750 million ton would be land-based or even more. Capital cost, FSRU is low, land-based is high. Time in service when you need an immediate need, so it takes lesser time to complete the project, whereas it takes a little longer time. So as I indicated, around 18, 24, 32 months and 36 months. Operating costs are higher in FSRU, land-based is lower. Unit regasification rate. So cost-effective way to meet low demand. Here, basically, when the demand grows, then you can then decide later. Here, the competitive as compared to FSRU. Here, the regas rate comparatively is less as compared to FSRU because the operating costs are less and utilization generally are better. Land is minimum requirement. Here, the land is required because you have to put all the facilities on the land and little expensive also. On the environment side, says a minimal impact of FSRU, but again depends on what kind of technology is used. Whether you are using, I think they said double loop, single loop, when the cold water goes to the sea, whether it is allowed or not. If you have to use power from FSRU, then the costs are going to be higher and the impact will be different. But here, the full environment assessment have to be done, though it is not considered. Otherwise, there is nothing effluents are coming from this terminal, but still the full assessment is required to be done. In case of FSRU, flexibility is low in terms of utilization, but it is good in case when if the demand after some time it is seen that is not there, then you can relocate this FSRU from one place to other places. Whereas in the land-based terminal, once it is constructed, it will remain there. Scalability, which is also very, very important, that is a limited scalability because one FSRU, then you have to add. And from the point of scalability, the land-based terminal is a good option. As I'm now shown, the Dahej terminal where it started with 5 million ton, when the demand is growing, I think it remains always in the expansion mode. So it has reached to a level of 17.5 and now it's going to be 20. Had it been FSRU, probably then we have to install more facilities somewhere for increasing the demand. So one have to take into account the site-specific condition, site-specific demand of gas, immediate need, what are the expansion plan in future, whether demand is going to increase, whether the immediate funds are available, or whether you are dependent on somebody providing you a floating unit and you will hire for that. So, and plus also another important factor is in case of an FSRU, in case the site which is selected, it is prone to cyclone, regular cyclones conditions, then probably then you have to move the FSRU from the place to go to high sea somewhere for the safety reason. And at that time, there may not be any gas because there is no storage on the land. So, but if you have any alternate arrangement, that's good. If it is not, then the customer would be concerned about availability of the gas. Whereas in the land-based, because we are having storage tank available on the site, if ship is unable to take berth, then at least from the store, whatever the LNG is there, then the continuous regasification continues. So these, I think, consideration have to be carefully examined before taking a decision on FSRU or land-based. So FSRU enjoy the advantages where considering economic efficiency, flexibility, responding time to the requirement and environment protection, whereas the land-based terminal, due to its better peak shaving ability and expandability, can easily deal with seasonal fluctuation in demand and fulfill national strategic storage demand in comparison to FSRU. So these are the basic difference in these two. Both are now working technologically, they are okay, but I think the decision have to be taken which one is good for a particular site and particular conditions prevailing at that time. Another thing is important that one have to decide when building a regas terminal whether it is going to be a project company who is building LNG terminal. They are going to be the owner of the gas and selling gas. It is a merchant structure where the project company who owns that LNG regas facility, so they directly enter into an agreement with the LNG supplier. They have the LNG SPA and also the shipping arrangement done, or shipping is done by LNG supplier, then it is a direct supply. So it is a direct agreement with the project company who buy LNG, and then they sell gas to the gas off-taker, whether one off-taker or multiple off-taker or multiple consumers. It depends upon the model which has been created. So all the risk with respect to the LNG volume, LNG price, and related remains with the gas company because they own the LNG and they supply gas. Though this company would like to sign a materially back-to-back agreement with the gas off-takers if they are the aggregators, and try to insulate itself whatever could be possible from the LNG price and LNG volume, and including the foreign exchange. So this depends upon what kind of financial model is done. So this company then take the other activity of the EPC contractors for construction of the terminal. They also, because for operation of whether they need a terminal operator or they do it themselves, and plus there would be a port operator. Port means that who will provide the port related facility, or it may be owned by the project company itself. Funding would be done by the shareholders, could be international lender, could be domestic lenders. So this is the one structure. So again, I'll give you an example of the Haze. The Haze started with this structure with a multiple off-takers, and then the direct contract with the LNG supplier for bringing that LNG, having responsibility to complete this activity, having responsibility for a project finance for the terminal, and having hired ships for taking that LNG from here. So this is one model. Another model is a tolling structure. Under the tolling structure, the responsibility of buying LNG and taking gas is basically remains in between. It may be a gas utility company, or it may be an off-takers who would be or a user of an LNG facility. It could be one, or they can be multiple. So they take a call with the LNG supplier and shipper to buy LNG and get it transported, and they're the gas off-taker then who will off-take this gas from that LNG, this utility company or aggregators. And they will sign a tolling agreement with the project company who owns the terminal, and the rest of the other activity would be carried out with terminal owner and get their financing done based on that. So construction and operating risk related to the terminal remains with them, whereas the tolling structure, the LNG related activity and supply related foreign exchange remains with other entity that who take this. Both structure are in place. So one can decide which model is good, depends upon the risk potential risk appetite of that company, or the requirement of especially the off takers and that. or it could be a hybrid model that I mentioned about the Haze, where both the models are working right now together along with the terminal. So it has its own challenge, that has another risk involved into that. So in the terminal use agreement, especially in the tolling structure, the basic services are provided by the toller is berthing of LNG ship, unloading and receipt of LNG from the LNG vessel, and storing that inventory on their behalf in their terminal, because ownership of the inventory remains with the owner of the LNG, who is a utility or an off-takers or user of their facility. And they provide the pumping and regas and send out facility. Basically, this is the major activity carried out by them, and transportation to the delivery point. Sometimes it is very close, sometimes we are far from the terminal, depends upon what kind of a transportation facility is created for gas, and measurement and testing facility it's provided, and plus maintaining the inventory on their behalf and providing that information to the terminal. These are the major activity are there for the tolling company to do it on behalf of others. So the receipt of LNG, as mentioned, the title and custody and risk of loss, always title remains with the owner of that LNG. Custody is with the toller, and the risk of loss depends upon how much that agreement you have signed. If the risk of loss is with the tolling company, then they have to take care of that insurance activity, or otherwise that sometimes that because the LNG inventory is in their custody, so the risk remains with them. This is another activity they mentioned, that when the LNG loaded, they will do the measurement of the terminal. They have all the equipments for carried out, because the payment to the LNG supplier in case of DS supply is based on the quality and measurement is done at the terminal, and the terminal user should have that kind of a facility to do that service. They will also have an agreement in place that in case the LNG which is unloaded or which is likely to be unloaded, whether it meets its specification, if it is not, then what would be the conditions of that at the time, whether they will refuse it or they will accept it. If they accept it, whether they will make good of that specification, whether it is feasible, then if there is a cost, then how to be shared. And these are some of the things that operating condition, because generally in LNG terminal, either you have one storage tank, two storage tank, and the users are if multiple, then you can't have a separate storage tanks available for each. Then depends upon the requirement and gas offtake. So it comes in the commingled with the other LNG comes in the terminal. So there is no separate storage tanks are provided. So in the agreement, tolling agreement, the detailed agreements are entered into with respect to failure of a party to provide LNG, or in case there is a failure from the toller to give delivery of regasified LNG at the send out rate which is required. Then in that situation, that what kind of a penalties and mitigation measures are provided. This is another activity that scheduling is done on a regular basis, because once the LNG cargo is loaded, how many days it is required to be taken for taking the send out and complete the evacuation of the terminal. It is not that once the LNG has come to the terminal, it will remain the terminal for a long time. If it is if the terminal owner and the owner of the LNG both have agreed that it has to be evacuated within a period of 7 days, 10 days, 15 days, whatever the flexibility available with the terminal and what are the requirement of the market, then these are decided accordingly. The nomination and scheduling is done. So downstream arrangement responsibility remains with the user of the LNG terminal and all pipeline related activity that they do it. On the shipping side also, these are the major activities, and it has to be properly captured in the tolling agreement about how the ship is going to, whether compatible with the LNG terminal, how the compatibility is to be ensured, and what are the requirements to be met for that. There are generally terminal rules have to be followed by any ship when it comes to the LNG terminal. So vessel berthing requirement, and this is also one of the major costs. Actually, the port dues and charges, if it is owned by the terminal owner, then it is a cost to them and they charge accordingly in the regasification charge. If it is a separate port, then this port division charge is paid to the port owner or port operator, whosoever it is. This is a major thing that is discussed. What is going to be a tolling fee or terminal fee? Generally, the system of charging tolling fee, one is a capacity fee, which is a usage fee, which is paid irrespective of its usage. Capacity fee is, once you book a capacity of 1 million ton, then you pay the charges, fixed charges of capacity fee, and the rest usage fee depends upon how much you use, and accordingly charges are fixed. In certain cases, it could be one bundle charges also, and also the mechanisms are built that other things. In case of how much utilization is allowed, 80% or 90% or 100%, depends upon that. For this, usage fee is basically use or pay charges. Again, there is another, if you are going to a different model, then there is a model is also where use or pay charges are charged. So different kind of model. And yesterday there was a question about how much is the regas charge generally from the LNG terminal. I think it depends upon terminal to terminal and the cost related to the terminal and how much flexibility that you are looking for your inventory to be kept at the terminal. There are different kind of charges, and plus the utilization of a terminal. So generally it is closer to $1 for a new terminal, but we have seen that all terminals, those who have been operating and they have the larger capacity, they even charge around maybe 50 to 60 cents, 70 cents, 80 cents, which includes all the charges, including your port and port related charges together. So this is generally a charge, but it depends upon terminal. Another important point of discussion the tolling is that a certain amount of gas is used during regasification when it is unloaded, and certain accounts gas remains unaccounted. There's a flare in the facility, but generally gas is never just flared, but it is the requirement of the LNG terminal that some amount of gas needs to be flared. So how this gas, when the toller is bringing is LNG, then for a system use gas, we say SUG or we say the boil off or gas, whether it is to be paid by the owner of LNG to the terminal or it is a part of the regasification charge. If it is separate to be paid, then certain percentage is agreed in advance, and maybe a reconciliation method is worked out in future, or it could be a standard charge which remains standard throughout the contract. Rest of the charges are more or less the same. That is, you had yesterday seen about any GSPA, invoicing, tax provision, and insurance and liabilities and force majeure. I will take only 5 minutes here. I will not take much time. The reason is because you will be having another session from Dr. Nawaz Ahmed. So generally in small scale, definition is that where the capacity is less than 1 million ton and vessel size is less than 60,000 cubic meters. But we are seeing the regas capacity much lower than these, what are the numbers have been provided. So generally the concept is there are 3 kinds of small scale or virtual pipeline or whatever we say that. One is that when there is no pipeline connectivity, or the pipeline connectivity is there but it is very costly and it is difficult to build that pipeline or whatever the reason is, then small scale could be an option for building an regas small facility there. Another is for the stranded gas. You have the field, but there are small amount of gas is there, and you can't transport it through pipeline. Then you put a liquefaction facility, and then through virtual pipeline route, then you transport that gas through trucks and other facilities. Third is that LNG is also transported through barges in a small quantities to a different location, especially when there is a requirement of bulk break operation. Then the small ships are used for this facility to take it away. Another operations for small scale LNG is coming for LNG use in transport directly as a liquid fuel as being taken into. So there are various uses. interest is getting generated, and if it is doable and feasible, then nowadays we are seeing that a lot of demand is getting generated for a small scale LNG. As I mentioned, off-grid customer for small power generator, maybe mining operation where the dumper and these kind of equipments operate on LNG, and also when if there is a pipeline disruption also, and then could be discontinued for that purpose. So ultimately, one have to see how much is the demand, what is the distance to be covered, whether it is 500 kilometer, 1000 kilometer, or if it is like 2000 kilometer. One have to take a view how much is the cost of the distance and carry that LNG, because that is going to be major cost of that. Then small facility is created, what is the cost is acquired and how much manpower. So overall, I think cost of implementing is to be considered while deciding the small scale facility. Thank you very much. I'll stop it here, and I will be very happy to take any question from the audience. Thank you very much.
Thank you very much, Mr. Garg, for this presentation. So now we will quickly move on towards a few questions. We have a question from Mohammed Shaheen. Shaheen from Agra, Islamabad. How many LNG carriers can be berthed with land-based LNG terminal at the same time?
You see, generally, if you have one LNG berth, then only one LNG carrier can be unloaded at a time. Generally, when the LNG berthing and deberthing activity and full discharge take 20 hours or maybe complete maybe 24 hours, depends upon the unloading rate. But if the demand is more, then probably we may have to build another LNG jetty, independent, separate. So then you can unload, maybe depends on the site condition, maybe 2 ships together, or maybe at a different intervals, because arrival of a ship, there may be a condition of a port that at the same time 2 ships cannot arrive at the same place. Then one ship is one berthed, then when the unloading is started, then you can berth the second ship, and then you can have a discharge accordingly. So I think it is a one LNG ship at a time, if you have only one LNG berth.
Okay. We have a question from Azhar from Agra, Pakistan. In case of virtual pipeline, can loading of LNG be made simultaneously in more than one LNG trucks?
It depends upon how many unloading bays that have been installed. Like I'll give you an example at Dahej right now, they have 5 bays. So you can unload 5 trucks at a time. Because the unloading bays of an LNG facility on truck, it is not that cost. It doesn't involve much more cost. So if the demand is more, then you can, and land availability is there, you can build an infrastructure and have a multiple unloading bays for unloading the trucks. So yes, it is possible. If you have only one, then only one truck at a time.
Okay. So another question from Muhammad Asad from Pakistan LNG Limited. This question is there any rule for creating relation between LNG storage and regasification capacity?
There are some rules available. I'm not sure. Is GIGNL has, I think, framed something. It depends. I think it depends upon the understanding, bilateral understanding of the customers and the users, and also in Europe, that's because there is a access regime for LNG terminal. So there are some rules there already in place. If you go to the website of Netherlands TTF and other places where these rules are very common for providing a facility and what kind of rules prevailing as charges available online. But in our region, I don't think that there is any standard rule is there. It is a specific requirement of I think bilateral.
I think Mr. Mathur wanted to add on something.
Before me, I think Balyan Saab, would you like to say, because he also raised this?
Just like add on that the capacity of a terminal also, there is a definite process to evaluate, because it depends upon you may store a larger quantity, but you may not be able to regasify at a required rate. So the capacity of a terminal is, there is an elaborate way to really evaluate what is the capacity of that in terms of regasified LNG offtake. Similarly, when you are really looking at storage and rate of offtake of regasified LNG, you need to really see what is your demand. There should not be a mismatch in the sense that you have huge storage, but you are not able to regasify and meet the demands. On the other hand, you may have smaller, just one tank, but you have high rates of regasification. Then you would not be able to really do it long time, because you need to have some minimum inventory required, technically required to keep the plant running. So I think it is a balance, and there are several parameters and a lot of elaborate analysis which goes into the process as to, for a definite range of offtake, what would be the vaporizers, their capacities, number of vaporizers. These are very specific things that need into designing of the plant that has to be done, and also what storage you require. Of course, larger storage is definitely advantageous to meet several other demands in future, but then to really optimize the cost, you need to really balance out both those things.
So just to add on, already Balyan Saab has said, there are 2 or 3 parameters that you have to take into consideration. One is the frequency of arrival of the ships, how much volume is coming into the terminal. 2, what is the discharge rate, what is the rate at which off-takers are willing to take the gas. Third is your regasification facility, what is the rate at which you can regasify. And then fourth is whether you want to use the facilities as storage, even for arbitrage, trading, or any other activity. So these 4 things determine what kind of tankage, what kind of capacity, and what kind of storage you want to create. So there are terminals which have 7-day cover. There are terminals which can afford 15-day cover also, and there are terminals which the discharge rate and the arrival rate of ships and the volume, they match. So there you don't need more than 2 terminals, one for the intake and one for discharge.
Okay, thank you. So we have a question from Imran from Agra, Pakistan. What are the acceptable limits of boil-off gas and retainage in a land-based LNG terminal and FSRU?
So for land, should I answer?
Balyan Saab, you may speak.
Actually, the technology has evolved over a period of time, and we've had earlier much higher boil-off rate, because LNG keeps on boiling all the time. So it is very important to really, and boil-off means if the vapor escape, you are having loss. So it is natural for any terminal operator and LNG owner to see that the boil-off is minimized, and whatever vapors are there, they are recondensed and brought it back. So there is a minimal loss. So over a period of time, we have seen a lot of development in terms of the containment system. How do you reduce the boil-off? And also, if there is certain level of boil-off, then you have recondenser attached to that whatever vapors come in, you again recompress that and form liquid and capture them for your use. The range had been earlier from 0.25% to present day full containments are just about less than 0.1%. Membrane ships have come to 0.07% or even less. So it is said that in a full containment tank, if you keep a cup of tea today, you can drink that tea next year at the same time, which will be more or less same hot. So this is the kind of efficiency that these containment systems have, and they are required for this kind of business. So the technology has moved, and we have majorly the nickel steel, bar, and stainless steel as the major component used, but the insulation, in between insulation, there are several new advantages and new products that have come in, which have enhanced the efficiency. Polyurethane and other multiple layers of insulations have come in, which are lighter also, which are very effective also. So it has improved from, say, 0.25%, which was very high, to about 0.0507% range today.
Those are the
so would you like to add on, Rajiv, anything?
Yes.
I'll just
that's fine, I think.
no, I'll just add one
The
thing.
efficiencies are growing, and therefore the rates are coming down now. That's
Yeah, that's right. That's right.
So thank you very much. Now I think we are finished off with these questions. I would again repeat to the participants that this is an interactive online training. So I think more and more you should get involved with the experts more and more on the one-to-one questions. And if you would like, we could also allow you the opportunity to have a direct verbal contact with them. So if you want that, otherwise we can carry on with these written questions and then asking them on your behalf. So, ladies and gentlemen, we would like to take a quick, short 5 minutes break at this time, and we would meet again at 11 hour and 7 minutes, and then we would start with the presentation of Dr. Nawaz Ahmed, who is the director of SAARC Energy Center. And till then, thank you very much again, and we'll see each other in 5 minutes time. Thank you.
Have a cup of tea, sir.
Broadcast is over now, or it's still on?
Sir, the broadcast is being continued, so you can just mute yourself and just unshare your webcam, and then we can meet after 5 minutes. Good morning and welcome back all the participant speakers. So we move on with our today's session. So on the agenda point, we have a presentation on the techno-economic analysis of virtual gas pipelines, LNG on wheels. The presentation shall be delivered by Dr. Nawaz Ahmed, who is the director of SAARC Energy Center. The details of the presentation include detailed capital and operating cost of entire LNG supply chain for varying distances and volumes of LNG supplies. I will shortly, in a brief intro, Dr. Nawaz Ahmed holds PhD in Land and Water Resources Engineering geological carbon sequestration, and MSc in Sustainable Energy Engineering from KTH Royal Institute of Technology, Stockholm, Sweden. He holds BSc in Mining Engineering from UT Lahore. He is an energy professional with over 20 years of experience in the energy sector. He has been serving Ministry of Energy, Petroleum Division, Government of Pakistan since 2002. Prior to joining Ministry of Energy, he served in the private sector. At present, he is looking after the affairs of LNG and LPG at the Ministry of Energy. His experience covers upstream, midstream, and downstream petroleum sector, technology, policy, regulation, and economics. So we would request Dr. Nawaz Ahmed to start his presentation. Over to you, sir.
Thank you very much for brief introduction, and assalamu alaikum, and good morning everyone there. Today I'm going to present one of my study on virtual gas pipeline. The talk will cover techno-economic analysis of LNG virtual pipeline. This study was prepared myself and presented in Gas Tech 2020 last year. Next, with a slide. Okay, first of all, before I start my presentation, there is a disclaimer which is important. I want to declare that this presentation is based on my personal study, which was presented in Gas Tech 2020, and the contents of the study no responsibility on either SAARC Energy Center or my employer. So the outcome of this study are not any project specific, but very generic in nature for the purpose of conducting this study only. My presentation will contain brief introduction of virtual versus actual pipeline. Then I will talk about my study results. First, I will speak about base case modeling, then sensitivity analysis, and then I will, in the sensitivity analysis, I will speak about the diesel versus LNG powered truck fleet. Next. So here we see that conventional pipeline transportation of gas from LNG port terminal to the consumer required physical pipeline, which is capital intensive. LNG is regasified at the terminal. Gas is supplied to the consumer through pipeline network. It is relatively non-scalable and limited to gas consumers en route only. Whereas LNG tankers, which is virtual pipeline, it is less capital intensive. LNG is transported in road tankers, or it can be transported through train. LNG is stored and regasified at the consumer premises. It is easily scalable, and it is relatively flexible compared to pipeline access. Next. Brief components of virtual pipeline. No doubt it contains import terminals, but after import terminals, it needs truck loading facility at the import terminals. We need tankers fleet according to gas supplies and distances, and we need also satellite storage and regasification facilities at the consumer premises. Next. Before I display the contents of my own study, it is important to refer some base case study. So here, one example from transport of LNG from Pennsylvania to Massachusetts, about 570 kilometers distance. So in first mode, only trucks are used, and the other mode is also intermodal, where truck and railway combination is used. So price varies from 64 cents per MMBTU to 85 cents per MMBTU for a distance of 570 kilometers using these ISO tankers. Next. Next. So here is a base case input parameters which I use for developing the techno-economic analysis. Brief, the study of economics of this entire LNG supply chain, including terminal facilities, truck loading facilities, truck fleet, then satellite storage and regasification facilities at the consumer premises. We have two variables mainly. One is the how much gas we need to supply, and at what distance we need to deliver the gas LNG to the consumers. So gas volumes and distance, these are the variables. For my financial calculations, I have used equity interest rate 19.2%, similarly debt interest rate about 18.8%. D, then when I conducted the study, the price of LNG was $6, so it can vary depending on the market situation. Market margin on top of the DES price, what you are going to deliver to the consumer, this is the market margin. It means if DES price is 6, you can deliver at $8.42. Then on this base, on this market margin, I have conducted this base case study. I will indicate how this market margin affects the profitability and viability of this pipeline with respect to market margins. I have taken project life 15 years next. So in base case study, the total capex of the terminal development, it varies with how much gas you need to handle. So we see that for 100 to 600 mmCFD, this is the parameters I have used, range of gas required. So we see that with increase in gas delivery, we need to spend more, capex. Similarly, for truck fleet, higher is the volumes we need to deliver, and longer is the distance we need to deliver, we need more capex on that truck fleet. So here is the satellite consumer facilities capex. So with the increase in volume, this also increases, but it is not dependent on the distance either. So total capex here, combining all these main capex requirements, we see how the total capex increases. Next. How much truck we need to deliver certain amount of gas and at what distance? So we see that with increase in gas delivery as well as increase in distances, we need a larger number of trucks. So we see that if we want to deliver 600 mmCFD at a distance of 1,000 kilometers, we need about 2,700 around trucks. So, and if we are interested to deliver at 250 kilometers, accordingly the truck numbers reduces to about 700. So how many trucks we need to load per day, this also depends on how much gas we want to deliver. So it is not distance dependent. Next. Now we speak here the transport OPEX, how the operational costs dependence on the gas volumes as well as distance. We see that it is first of all transport boil off, how much boil off takes place in terms of US dollar per MMBTU. We see that longer is the distance, higher is the cost of boil off per MMBTU. Similarly, transport OPEX, the driving and operating cost of the trucks, longer is the distance, we see that higher is the transportation cost. Here I have also included a management OPEX, which is relatively constant here in my model. Next. Here we see that combining all operational cost, how the total operational cost vary. So with longer is the distance, we see that the higher is the total OPEX. Next. Here are the results about project payback and IRR. We see that project IRR based on the given parameters, where the 2.42 was the margin of gas supplies on top of the DES price. We see that the project IRR vary from 20%, 25% to maybe over 100%, depending on where we deliver the gas and how much we deliver the gas. Let's say with the longer is the distance, lower is the IRR. So because of higher operational and capital cost. So here the discounted payback period vary from about it is less than 4 years. So shorter is the distance, shorter is the payback period, better is the economics, and higher is the IRR. Next. Sensitivity analysis with respect to sales margins. If higher are the sales margins, if the market is so that we can sell LNG over and above DES price of $6 at, let's say, delivered price is $9, it means we have a better IRR. So IRR may vary up to 55% from relatively 10% onward, depending on, of course, the gas volumes and the distance. Next. Here in this sensitivity analysis, I have also studied what about if the trucks are diesel fired versus if the trucks are LNG operated, because technology has developed that LNG fired trucks are available. Their engine operates on LNG fed from maybe from your tanker, main tanker, transport tankers. Next. Based on the cost of the diesel trucks versus the LNG operated trucks, running cost, including the diesel price versus LNG price and other costs, we see that the economics of operating LNG trucks is relatively better than operating the diesel trucks. So there is incentive to shift your truck fleet from diesel operated engines towards LNG operated engines. Next. So here are conclusion takeaway from my study and presentation, that gas supply through LNG tankers is a flexible, scalable, and gas can be delivered at competitive prices compared to the pipeline as well. But depending on the distance between the port terminal and the end consumers. LNG fuel trucks are more economical and less pollutant than diesel ones, particularly for long haul distances. Efficient operations of virtual pipeline requires a precise project assessment and development, because it is very sensitive. If the project is assessed properly and have better, studied the sensitivity analysis, better payoff and better management of the project. Next. Here is a 1-minute video for just to tell how this LNG virtual pipeline plays. Thank you very much. With this, I end my presentation and now open for question and answers. Thank you very much.
Thank you very much, sir, for your presentation. So we have a question from Mr. Arsalan from Agra, Pakistan, and his question is: what's the conversion cost of diesel trucks to the LNG trucks?
Basically, answering directly to this question is relatively tough. The market is developed, let's say in Sweden, a few truck engine manufacturers. They are, it is not conversion into diesel engine, but they are developing directly the LNG fired engine. But conversion is also taking place, but exact cost, conversion cost, I can't tell at the moment.
Yes, sir. Maybe Mathur sir wanted to add on something.
Yeah, please.
So in India, our experience is that LNG truck costs about 10 lakh Indian rupees more than a diesel truck. And of course, you can convert diesel engine also into LNG. You can also use diesel engine fired by CNG. You know, you start off with diesel and then you inject CNG, run 80% of the time on CNG, and then go back to diesel while starting and while switching off. So all those that is possible, but 10 lakh Indian rupees more is what is spent in capex.
Okay.
Just to add to the Mathur comments, yes, in my model also the LNG fire trucks are costlier as compared to diesel trucks, but the operational cost over the period of project life, at the end they are relatively cheaper.
Just one more point, sir, that now that we have shifted to BS6, what you need for emissions is much more higher level of equipment required to ensure that emissions are matching the BS6 standards. So for that we require 7-8 lakh rupees more in terms of emission control measures on every truck. So virtually the cost of a BS6 diesel truck and LNG trucks in India now are coming almost at par.
Thank you, Mathur.
So a similar question related to this question is from Mr. Arif from Agra, Pakistan. His question is, what is the cost of setting up a modification facility for conversion from diesel to LNG operated trucks?
Thank you, Arif sir. Maybe Rajiv may give exact answer from Indian example. Exact answer like first question I could not answer because I am not, at the moment updated of shifting from diesel to the LNG. So I request Rajiv if he can add to this question.
So, sir, no conversion facility has been set up in India as of now. What we have attempted is to ab initio create LNG trucking facilities, either LNG as a fuel or using diesel trucks with LNG as a tankage, which could be utilized in industrial units. So there is no, quantification or number that I have on conversion in Indian context.
I think Balyan sir wanted to comment something.
Yeah, I think excellent presentation, Dr. Nawaz, very interesting. I have just few observations. I see that your debt rates and also IIR are so high, actually, very, very high on that. So I'm not sure whether from the market perspective, is it reasonable to assume that? I feel it is very high. Also, I think considering the practical aspect of really implementing such projects, a large fleet of around 2,700 trucks. I'm not sure what capacity you have taken there, but it is a very large fleet. To operate that and manage also is a challenge, considering, I'm not sure, but in some of the Indian roads, we find it very difficult to really manage that this thing. Even the loading facility for that much amount of LNG would require multiple bays there, maybe a few dozen bays. If you work out per day kind of a loading, it would run into hundreds of loading. That may be also this thing. So I think I see that a train solution might be more doable to my mind and maybe more manageable, creating that facility there at the consumer end also. What experience we have in India, we have been doing this trucking of LNG for last almost about a decade. And there are a few dozen customers which range from, say, 150 kilometers to almost about 800 kilometers. And we have 10 tons to 15 tons kind of a capacity of trucks which are made in India. Now we have capability of making these cryogenic tanks here. They are put on normal truck chassis, and we've been doing it for a long time. All those customers which for them transportation cost included is still making sense to replace costlier fuels are fast changing to LNG, and this we have seen in areas closer to the LNG terminal. But for a long distance, I think still there are challenges, particularly for the automotive sector on a highway of about 2,000 kilometers. How do you create those facilities? That's a challenge that we are facing. But I think this is a very good solution to work on that, and I'm sure your model can be refined and really made more practical on that. But just few observations I thought I'll share.
Okay, thank you, Balyan. To your first observation that it seems very high IRR, in my financial model, I have used marketing margin of 2.42 US dollars per MMBTU over and above the DES price. So it all depends on what parameter market margins you are using in the model. So maybe you are not earning 2.42 dollars per MMBTU. If you are earning, it decreases accordingly. Your IR and payback period will decrease and increase. So all depends on actual market. So that's why I say that this is not some project specific study. This is just an indicative study. Depending on the results, depend on what parameters you are using, and in the sensitivity analysis, I studied this question that how our sales margin affect the project economics. Here, if we see that if the market margin is just $2 per MMBTU, and the customers are also at some distance and volume dependent, so our IRR decreases accordingly. So this is depend on the actual market margins operating in certain project.
Okay, thank you, sir. So we move on to the next question, which is from Jameen Shah. And to repeat again, kindly all the participants should mention which organization or which country are they asking the question. So his question is, what is the optimum capacity for setting up SSLNG facility?
What is optimum capacity? So if we, can you display my slide? Let's say it depends on all project economics. Let's say how much margin you get, and it depends on the distance actually. Shorter is the distance, better is the economics. So up to, I would say, 1,000 kilometer, the economics is very attractive. But again, it depends on the market margins, actual market margins. If the market is competitive, multiplayers are there. So might be in competition, your profits might vary. But shorter is the distance, better is the economics relatively because of your lower operating cost and and capital cost as well. If you go back to my few earlier slides where I have given some let's say distance. See here, just next to this one. So here the all depends on IR dependent upon your gas volumes. How gas volumes, higher is the gas volume, higher is the profit. But if the distance is, let's say, shorter, so if the distance is longer, your profit and your IRR accordingly decreases. So exact answering what is the optimum all depends on the market conditions and your operating cost and as well as the market margins.
So, sir, we have a question specifically for the Indian experts. What is the role of regulator in virtual pipelines in India? The question is from Misbah Ogra. And to add on another question, because it also looks to be similar to this question, it's from Mohammad Hassan Bhatti from Petroleum Division, Pakistan. How much LNG on truck is safer as compared to other fuels which are also transported in the same manner?
I think Dr. Balyan has a full session on this, and I don't know whether he answers it now or maybe.
I'll briefly touch upon that. It touches 2-3 areas of regulatory aspect. One is the safety concerns. Number 2 is the storage of the safety and the transportation. These aspects. So as far as safety is concerned, there are clear guidelines, standards given. How do you fabricate the tank, the material, the other equipment? That is very much clearly sort of stated. Those standards are being used for fabrication of the tanks. Yes, you need technical people, trained people to really operate that. So the equipment with that, the valves, the pumps and all those operations. So when you are having a truck operating, you need to have, besides the regular staff for taking, you must have a technician to really see that the procedure is followed on that. But as far as safety requirements are concerned, there are very clear standards which are being used right now, and they are pretty safe. Transport LNG, we haven't seen any accident or incident of that type. They are as safe as, and we have seen the safety comparison of LNG with other petroleum-based fuels. It is much safer as far as normal characteristics are concerned. So I don't think there is any issue. They're much safer, and we have had no accidents on that. There is a separate organization. There is a separate organization which gives the standards and certifies the drawings, designs, material and all. And the regulator in India has recently permitted that an LNG station, satellite station, dispensing unit can be set up in any of the geographical areas, as we call it, for the city gas distribution, irrespective whether a geographical area is allotted to a company A, even B, C, D company, anybody can also put up. So there is a freedom, more flexibility, and liberal market conditions have been created.
Thank you very much, sir. So we will like to ask just last question. This is from Salman from Agra, Pakistan. What are the operating temperatures and pressures of LNG in ISO tanks during transportation? And for how many days can LNG be kept in ISO tanks?
I will get help from Indian experts, but what I know, I can comment on this. With the innovation of latest technology, which is ISO containers, so they keep one at temperature of minus 162 degrees Celsius for about a week, and they have the capability of managing boil offs. Even some containers can manage zero boil off, and few containers, if they have the boil off, they can sustain the pressure up to a week a time about.
Okay. So any comments from Balyan sir, or should I move forward?
Yeah, I think that's what Dr. Nawaz is saying is absolutely right. The trucks can containing LNG, and if they can use the boil off as a fuel, then you can continue to keep the LNG tanks full for much longer time. But if you are not able to really do that, then 7 to 10 days is a normal time where even the smaller pressures, the tanks are designed to take up that much, and there's no problem on that.
Okay. So Balyan sir, I would quickly, I would ask your very brief reply to one short question. This is from Jamin Shah. I guess he's from India. Why is SSLNG not being implemented in northeast of India, where there is needed indeed a lot of stranded gas?
Well, I think what he's perhaps meaning is the standard gas means that gas that is available domestically, that needs to be liquefied actually, or compressed, and then taken on truck to a customer space. So the challenge there is, and there is a lot of studies, let me share with him, Mr. Shah, that there are several studies done for the northeast for the standard gas to collate all the gas, create a economically viable volume for liquefaction or for compression. Now there are technologies which are very much useful, and as I said yesterday, I shared that in some of the isolated small gas fields, compression is being widely used. So you produce gas, isolated one well, all gas is collected, is compressed into cylinders, and then cylinders are taken to this thing. So this is a slightly different model which is being used in northeast. For any isolated gas, the liquefaction cost would be very high. So it is a matter of economists to work out whether a liquefaction is a better opportunity and then transport, or compression is a better opportunity to transport and use it.
Okay.
Can I add on Balyan comments? Yes, I agree. If the distance is less than about 1,000 kilometer, the economics tells that compression facilities from the stranded gas is more economical. But if the distance increases from the production site to the consumer over and above 1,000 kilometer, then the option would be LNG. So because of longer distance. So for shorter distance, of course, the solution is compression of gas.
Thank you very much, sir. And I would request Dr. Balyan and other experts that if you have some studies which you are referring in your presentations or in your interactive sessions, you can just share those links or those reports in the handout pane of our software, and the participants can easily download those reports or those links during these sessions. Plus, we can also upload it on our website later on. So we close this session. Thank you very much, Dr. Nawasa, for your presentation and for other experts for their valuable comments. So we move on to the next presentation.
Just Mike.
Yes.
I'm very thankful. Before I leave this session, I'm very thankful to Indian experts who are providing the training, and very impressive your experience, what you brought in to this forum. Thank you very much again.
Thank you.
Thank you.
So we move on to the next presentation, which is on the gas supply and distribution. The content of the presentation is includes laying pipelines, pipeline tariffs, postalized unified entry-exit, agreements for gas supply transportation, and supply cum transportation. The presentation shall be delivered by Mr. Rajiv Mathur. So I would now request Mathur sir to start his presentation. Thank you.
I think I need access to the, yeah.
Yes.
Oh. Just give me 1 minute.
So Dr. Mathur is uploading his presentation. So I would take this as an opportunity to inform the participant that all these presentations will be uploaded on our website after the end of this today's training program. Plus, on top of that, you are most welcome to ask questions to the experts. It's an interactive workshop. You can type in your questions on the text box, and we can ask those questions on your behalf. Otherwise, you also have the opportunity to ask these questions directly with the experts, and we can allow you to ask them these questions verbally through them, just by permission. So over to Rajiv sir. Is it okay, sir?
Can you see the presentation?
Yes.
Yes, sir. It's
Yeah.
visible. Over to you, sir.
So thank you very much, Ehsan Saab, and thank you,
Yes,
SAARC
sir.
Energy Sector. Today I am going to discuss on the topic of gas supply and distribution. And my topic includes laying of natural gas pipelines. It talks about pipeline tariffs, how the pipeline tariffs, what models are there. And then in brief, maybe if we have time, I'll talk about the gas transportation agreements. I also have a presentation on transnational pipelines, but depending on time, I will either show it today or maybe we can take it forward tomorrow. Just before that, I would like to, tell you, how international agencies are looking at the scenario going forward. So, IEA talks of, a transition which is, targeted towards net zero carbon, emissions. It talks of, the LNG trade falling. It talks of, global supplies going down, and it talks of, huge investments which are happening, but which may not actually happen going forward. If we have to really go towards a net zero kind of a situation. So let me just hold on for a minute. I'm not able to see the entire presentation here. Okay. So projections are that, from 2021 to 2030, the actual investments in oil and gas sector in new projects would be about 350 billion US dollars, and which is much, much lower than kind of 150 billion dollars or thereabouts, which annually people are supposed to be spending to ensure the oil and gas that is required to be produced gets produced, going forward. And if we have to reach a net zero by 2050, then the demand of gas also is expected to go down. And what they project is that 50% of the gas at that point of time will actually be utilized in producing hydrogen and green hydrogen, which ensures that there is no carbon emission happening. Okay, it's again stuck. So just one minute, give me 1 minute. Somehow I'm not able to.
The next screen is visible.
It's visible?
Yeah.
So again another outlook has been created by Wood Mackenzie, and in Wood Mackenzie's outlook also they talk about either energy transition, if it is happening on a gradual basis, then there will be oil demand which will staying over 90 billion barrels per day till 2050. They talk about oil prices above $80 a barrel, and they talk about LNG prices between $8 and $9 per million BTU if a gradual energy transition happens. But if the temperature rise is required to be limited to 2 degrees centigrade by 2050, then the oil demand and correspondingly the gas demand, etc., will start peaking much earlier. Oil demand will actually peak around 2025, and there will be a fall in the requirement of oil, which may be around 70% below the peak levels by 2050 to reach that 2 degree level kind of a thing. And eventually, if there is no demand for oil, then it may trade around at $40 a barrel. But in all these scenarios, what is being talked about is that gas will still have a major role to play going forward, with or without 2 degrees, with or without a gradual transition happening. Gas demand and gas prices will remain resilient, and it may actually displace things like coal, oil, etc., but may have a very steady, maybe 20-24% kind of a share going forward. And going forward, more investments will go into gas production, operation, investment in pipelines and infrastructure, and probably oil. And again, their projection is that LNG pricing would be around $8-9 kind of a thing. These are only projections by entities. So all it suggests, again I'm stuck.
Next.
I think.
Sir, you have to click on your presentation instead of the software.
Okay, now I think it's moving.
Yes.
So my point is that whichever the case may be, going forward, we will need a lot of gas infrastructure to be put in place, because we've seen that in the past, unless you link the producer to the markets or production of gas with the markets, there is the opportunity of utilizing gas gets lost. And therefore, whatever you need that piece of a pipeline in between an LNG terminal and the final market. And also, as we've seen in the past, we need liquefaction facilities, we need shipping, we need regas facilities, whether they are in form of FSRUs or they are in form of land-based terminals. And then once you have those regas facilities in place, you actually need pipelines to transport that gas and deliver that gas to the end customers. And therefore, I mean, you all are experts. I will not dwell too much into details of these things, but these pipelines are essentially steel pipelines, which are high pressure pipelines. They are interstate or continental pipelines. In some cases, they cross the national boundaries also in certain cases. And, they are required to be constructed over long distances generally to take the gas to the end customers. So for that, when you create a pipeline, you construct a pipeline, you need a right of way, you need maybe something like a 50-foot right of way, and you need about 1.5 or 2 meters kind of a depth underground for these pipelines to be laid. There are then compressor stations, and these compressor stations are essentially there to push the gas forward. When you in high pressure pipelines, generally the pressure is between 90 to 100 bar. In India, we have an average of around 92 bar or so, but they are designed for even closer to 100 bar kind of pressures. And but depending on the size of the pipeline, depending on the volume that is required to be pushed through the pipelines, it can only take you to a distance, maybe 200, 300 kilometers at best, before the pressure loss, does not allow it to flow any further, the kind of volume that you require to be pushed. So at intermediate stations, intermediate locations of maybe 100, 200, one has to design that properly. You have to put compressor stations, and these compressor stations then again repressurize the gas and push the gas for another 200 kilometers or thereabouts. And you have to design the compressor accordingly so that suction pressure is equivalent to the tail end pressure of the gas that is coming in from the upstream side, and then make it another maybe 90 or 100 bar or whatever to push it another 200, 300. So an interval of 100 to 200 kilometers, these kind of compressor stations are required to be put. And then, in certain countries, there are storage units also there. And these storages are used primarily for storing gas. They are either cavities, or they are depleted fields, or they are salt caverns. And in distribution networks, localized distribution networks, there are gas holders also, but they store very little volume of gas. So essentially, depleted fields are being utilized where gas is pumped in non-season, or when it is not required in the manner it is required in peak times, and then it is taken out on occasions or times when excess volumes are required over and above the normal requirement of gas. And they are used basically for balancing purposes between the supplies that are happening from either a regas facility, or from domestic sources, whatever gas is getting produced. These storage facilities, they supplement the availability of gas, and then they are reinjected into the pipeline and taken to over longer distances of 500,000 kilometers or so, to the markets where the gas is to be utilized. So storage fields play a very important role. There are two kinds of storages. One is the pipeline itself acts as a storage. So the more the pressurizing of the pipeline, the more the amount of volume that you can store within the pipeline. The other is the storage fields for balancing purposes. Then, of course, you have the option of getting the gas either from a LNG liquefaction facility, which also forms part of the pipeline infrastructure, or you have domestic fields which feed into this, and then to supplement that, though, there are storage fields. So all this entails the entire pipeline infrastructure which has to be set up in any nation to ensure the requirements or demand of gas are met. Now, quickly coming to, I have just one illustration about India, where, over a period of time, we realized that our domestic sources are not enough to meet the domestic requirements. So we started early and we decided around the year 98, 99 that we need to import gas because our domestic, we were able to meet the 100% requirement of our domestic gas requirements demand till the year 2000 or so. But we realized very soon that this gas is going to fall short, and we will need import of gas either through pipeline mechanism from other countries or through LNG mode. So at that point of time, this Petronet LNG company was created, and they set up the first terminal at a place called Dahej in Gujarat. Since then, several new terminals have come up in India, and at last count, there were about 8 or 9 terminals which were in operation. The largest one, of course, is at Dahej, which has a capacity of around 17.5 million tons. And as Mr. Garg put it, capacity is being expanded to over 20 million tons going forward. Then a private company, Shell, put up one terminal at Hazira, which is also in Gujarat in India. And they put it as a merchant on a merchant basis without any tie-up upstream and without any tie-up downstream. So that was the first private investment that came into the Indian shore for a LNG regas facility. Thereafter, several other terminals have been set up on the west coast as well as the east coast, and all these terminals are supplementing the domestic, availability of gas which is coming in from domestic fields. So essentially, what is required is good planning in advance to ensure that import facilities, whether they are LNG or whether they are in form of FSRU now, get set up in time to ensure that the demands which are over a period rising, energy requirements which are rising and are being met through natural gas, are adequately supplied, through imports as well as domestic requirements. So today we have regas capacity of about 40 to 45 million tons per annum already existing and in operation. About 20 million tons is in construction. About 10 million tons is construction stage, should I say, which will come into construction phase in the next 1 or 2 years. And we will have around 70-75 million tons kind of a capacity in place in the next 3-4 years time. Beyond that, new capacities are being planned. And as in the morning it was put that we already have one FSRU also in operation. There are 2 or 3 others which are being discussed and in a planning stage as of now. And depending on the requirements, more facilities will be set up. And all these facilities essentially will get connected to the infrastructure that is getting created in terms of the pipelines that are being laid. Quickly coming to pipeline construction, I will not take long because all of you gentlemen know about pipeline construction. Pipeline construction is one of the most complex things, although it looks very simple, but since it is a longitudinal kind of a construction activity which takes place, it requires a lot of acquiring of lot of land. And if the project is not conceived and planned ahead in time, then it can lead to delays, cost, escalations, and various other associated problems, including environmental issues. So a lot of planning and scheduling and budgeting is required to be done much ahead of time, and the right time of technology, the right kind of designing and other things, and execution partners are required to be in place to ensure that the gas pipelines get constructed properly and they get connected to the supply sources as well as the demand centers well in time and in synchronization with the either the import facility which is happening or the new gas that is coming in from domestic sources and the markets which are getting developed. So in India, we are actually, at a stage where a lot of new domestic distribution networks are getting created. A lot of new, fertilizer plants and refineries and other petrochemical plants are coming up. So scheduling of these pipelines to ensure that they get connected in synchronization with the upcoming of these projects is essential. So a lot of thought has to go in to ensure that these projects are implemented, well in time. We all know that pipelines require to be laid over different geographical areas, so the terrains can be difficult. Although the best thing about a pipeline is that it is very cost effective as far as transportation costs are concerned. So while we talked about 65 cents to 85 cents in the earlier presentation on transporting LNG over longer distances, a pipeline, if it is efficiently implemented, could deliver, over a couple of 100 kilometers in less than 50 cents, transmission cost. So it is an efficient way of transporting gas. It requires very low energy, if it is designed properly, and it ensures steady and constant supply of gas over longer distances, over long periods of time, 25, 30 years or thereabouts. But there are challenges which are to be overcome when you need to construct or lay a new pipeline. Even when you need to augment the capacity of a pipeline, there are issues, relating to environment. There are issues relating to land acquisition. There are issues relating to right of way. At times, we are required to lay the same a different pipeline with a different product in the same right of way that we have laid an existing pipeline. And there are instances in India where, because of the non-availability of land, or because of people not willing to part with the land for these kind of activities, the same right of way has been used, that 30-40 meters that is available, to lay a LPG pipeline, to lay a product pipeline, and also to lay a gas pipeline, over maybe 3 or 4 meter spread differential kind of a thing. Then there are difficult terrains which are required to be surmounted. There are mountains, there are rivers, there are so many other things. Then there are local, regional, national, international issues depending on what kind of a pipeline is required to be laid. And at the end of it all, you design, lay, implement a pipeline, and you think that you have done your job connecting a demand center with the supply center. But as we all know, requirement of energy is growing. Requirement of gas will continue to grow, and especially in South Asia and nations there in SAARC countries, the energy requirements and per capita energy use has been very low. So with the modernization and with the growth, with the GDP growth, the energy requirement per capita is also growing. And end of the day, we find that there is a capacity constraint as far as the infrastructure that we have created is there. So one has to plan well in advance to ensure that we don't end up with a capacity constraint very soon. But of course, you have to augment capacities through various mechanisms, lay different more pipelines if required. I will not dwell into how pipelines, what is the project life cycle. We all know, and you can read it at leisure later on. But it's quite a complex exercise that one has to undertake to ensure that all activities are well planned and executed to ensure that a pipeline comes into place. And then there are stages of pre-designing, there are stages of pre-construction, then there are activities which relate to construction, testing, commissioning, and handing over and operation of these pipelines. And each one is a complex thing which each entity, I'm sure all of us know, what it requires. And then, of course, these are some details about pre-construction and construction process and activities. So you have to do a lot of resource and equipment planning. You have to do a lot of scheduling, and then you have to do a lot of mobilizing of manpower and equipment. Today, we are running short of people who can actually implement on the ground these kind of activities. There are big entities which are engaged in, construction of pipelines and other things, but availability of adequate manpower who are trained and adequate equipment which is available in time also requires a lot of pre-planning activity to be done. Then after all these things are there, then you have to pre-qualify. A lot of things like welding, etc. of a pipeline requires specialized people with specialized training and procedural approvals, etc., which is required. So all this requires, and then at the end of it all, the training of on safety, because these are things which are which are which have a safety issue as far as the product is concerned. Not only that, while in constructing also a lot of safety training is required to ensure there is no mishap, while the pipeline gets laid. So one has to get when you need to construct a pipeline, you have to get the approvals for route, you have to do a lot of surveying, you have to do clearance of ground, grading, trenching, springing, bending. All kinds of these activities are specialized activities. Welding, as I talked about. Then, installing valves and equipment. Then at the end of it all, you have to ensure that the pipeline is robust enough. You need to do hydrostatic testing, and then thereafter commissioning, etc. And then you restore the land and give it back to the farmer or whosoever has given the land for the pipeline. I'll skip all these slides, but you can read them at leisure. But they just talk about how difficult it is for a pipeline infrastructure to be laid and what the process involves. These are some pictorials of how a pipeline construction activity is happening. And so next, coming quickly to what are the safety norms and regulation. We know ASME codes are required for designing material, equipment, welding, fabrication, commissioning, etc. These are the standards which are followed. And then in India, we have something called T4s regulations. And these T4s regulations are technical standards and specifications for safety standards, as to what kind of a material you will use, what kind of equipment you will use for construction of a pipeline, what kind of welding standards are required, what kind of qualification of a welder is required to be done, what kind of pipeline system components and how they are need to be fabricated, and the procedure required to ensure that robust safety norms are adhered to. And then it also talks about designing, installing, testing, operation, maintenance, procedures. So all that has to be rigorously followed, and I'm sure every other country also has these kind of regulations in place. It also talks about things like corrosion, because if gas is not treated properly, and if you have sulfur or H2S or any of those corrosive things, and also the soil has a lot of corrosive elements in it. So we have to ensure that a pipeline, once it is laid, is protected and integrity of the pipeline is maintained over long times, maybe 30, 40 years. And for that integrity to be ensured, lot of activities are required to be done. There are some pipelines which are required for SAARC gas service. So these pipelines are essentially pipelines which emanate from a gas source, whether it is offshore or onshore, where gas comes out with a lot of impurities. There is water, there is H2S, there are so many other impurities, mud, sludge, and all those things. So for SAARC gas service, there are different kinds of standards and requirements till it is purified and then made dry and then transported. So all those standards are given, and one has to adhere to as far as the pipeline running and operation is concerned. And then it also, in Indian standards, it also defines the periodicity at which different times of critical activities are to be performed. It talks about reporting of various compliances that are to be done, periodicity of reporting, whether it is annually or half yearly or maybe biannual or whatever. And test records are required to be maintained for various things like radiography, ultrasonic tests, hydrographic tests, cathodic protection, and to ensure pipeline protection is adequate and integrity is maintained, and all kinds of other things, including leak detectors, flooding systems. All those things are required to be. And if you are looking at operation of pipelines, these are now all done remotely, and I'm sure they must be done remotely in other countries too. So they are there is an operating control room, and these control rooms are linked to remote terminal units, and these remote terminal units collect information from real-time information and convey it through the satellite and microwave links, or through cellular phones or any other communication mechanism to the central control room, which ensures that the pipelines are run flawlessly. So there are field instrumentations in place. These instrumentations, on a dynamic basis, gather data about the kind of flow which is happening, the pressure, the temperature, and all other things. At every distance they are put, and all these data are then controlled and maintained to ensure the integrity of the pipeline system, and the flow is happening, and the hydraulic conditions, the pressures, etc., are maintained properly. And then there is a supervisory control and data acquisition system. These are softwares and applications which allow access to various things, like if there is a leak which is happening over maybe 100, 200, 300 kilometers. So the drop in pressure will predict whether a leak is happening or likely to happen. For a product pipeline, it will talk about how the batch is moving and where when they can push another liquid or product. It also talks about if you put in a pig, where the pig is, and how, and pig also is gives you senses and gives you all the data of whether the thickness of a pipeline is proper, or whether there is a pitting, or there is an issue relating to some water which is contained within the pipeline, things like that, or some corrosion which is happening. And then it also does predictive modeling, looking ahead as to predictive maintenance if it is required, or if it requires some kind of operational philosophy to be changed. So all these software systems allow all this to ensure a pipeline operates flawlessly over 20, 30 years. Of course, this is a depictive diagram which shows how over longer distances the signals are tracked by the RTU from the tracking equipment that is installed, and through satellite or whatever mechanism it is sent to the main control room, where the entire operation of a pipeline is managed. Coming quickly to common carriers and contract carriers. A contract carrier is a contract between a shipper and a transportation service provider, an entity which owns and operates a pipeline, provides capacity to any shipper. Now, in certain cases, the transporter himself may be the owner of the commodity and is utilizing the pipeline directly, or the entire capacity of the pipeline himself. In other cases, or by regulation in countries like India or elsewhere, some capacity of the pipeline is required to be either contract carried, or common carrier capacity is allowed to be given to third parties. So in which case, a contract carrier is one where, beyond your own requirements, you give some amount of capacity on a contract for transporting or shipping volumes of gas from X point, which can be an import terminal, or to a market or a exit point. And those capacities are booked, for periods not less than 1 year. That is in the Indian context. In other countries, the regulation may allow for a longer period or a lesser period. So if you want to transport or ship X BTUs of gas, then you have to define from where the gas is required to be picked up or shipped, and what is the exit point. And then you have to define at what point of time the capacity, the volumes would be available, and then at what point of time it has to be delivered. So that is a contract which is a gas transportation agreement or transmission agreement, which is signed between two parties. This is for a period not less than a year, and the shipper is obligated to deliver the volumes at the inlet point of the pipeline system. Thereafter, the obligation of transportation and redelivery rests with the transporter. And the content, or for that matter the commodity, the title of that still rests with the shipper. Of course, as in the morning Mr. Garg put it, if the obligation is required to be shifted to somebody else, then there are hedging mechanisms or risks which are required to be mitigated by the shipper if the contract so provides or requires, and then they do that accordingly. Now, natural gas pipelines are natural monopolies. We all know about that. And these monopolies are therefore required to be regulated, because, in case of other products, you may have alternate mechanisms in place or alternate transportation methods available, which or parallel competitive mechanisms which are available for delivering a product. But in case of a natural gas pipeline, once it is laid, duplication of those pipelines with a competitor does not nearly happen unless that pipeline system gets saturated. So therefore, the concept of natural monopoly is there. One, because it's not easily replicable by a competitor or a rival or a third party who can give you the same service from same point to the same discharge point. And therefore, the consumer interest is required to be protected, and in order to promote competition. And for that, there are regulations which come into play, and people have to ensure that they abide by those regulations, allow access to capacities on a non-discriminatory basis, and for any shipper to utilize. And these things, I'm sure, will be dealt in the regulatory session, which is going to follow very soon. So shippers enter into a contract, either on a contract carrier basis, which is for a year or more, or if they have volumes which are required to be, transported and deliver over shorter periods, then they enter into a umbrella gas transmission agreement with a transmission or transportation entity, and those entities then you have to sign a confirmatory note as and when those volumes are available with the shipper, and it defines the day, time, and the entry and exit points at which the gas is required to be available and redelivered. And it leads to development of competitive markets, because even if the transporter himself has his own gas, there are other shippers who may have gas and who may be looking at delivering the gas to the same markets. So at the burner tip, whosoever becomes competitive or provides better terms and conditions is the one who is able to supply, deliver the gas and acquire that market. So this is to create a competitive position. Non-discriminatory access of pipeline systems are allowed. I will not go into details, and maybe you can go through these slides later on. But then coming quickly to transportation contracts, we discussed yesterday about contracts. So these are contracts where both parties have the rights and obligations. There are certain condition precedent, and there is an operating code which the regulator or the government or the entity who are operating the pipeline system define as to how, if there are several types of gases, in the sense that there are several shippers putting in their gas, how they will behave, how the transporter will behave, how when at the redelivery point, if there are different shippers whose redelivery is to happen, in which manner it will happen, what will be the proportion, kind of thing. All that is defined. What is the pressure at which it is to be redelivered, kind of things. And then we talked about capacity tranche. So these are tranches which are available in a pipeline system on a dynamic basis. Now transporters are required to display what is the total capacity of gas that can be shipped from point A to point B. What is the pressure? What is the kind of quality of gas or the other parameters which are required at the entry point for gas to be allowed to enter the system. Then they define as to what capacity is already booked by either themselves or any shipper A, B, C, D, E. And at the end of it all, they have to define as to on a day X, which is T+1, that is tomorrow, how much capacity is available as common carrier for anybody else to ship. And that capacity is on a dynamic basis. If people are either booking or releasing, it is known on maybe a hourly basis, or if it is dynamic, on a dynamic basis. Any point of time you can check on the portal what the capacity is. And suppose somebody has X volume of gas, they find a customer at the other end, and they know that gas can be delivered at the entry point at the terms and conditions and specifications that are required, and they then contact the transporter. And normally these kind of transportation contracts are signed well in advance, and only a confirmatory note is signed at the time when the shipper discloses that he wants to use the common carrier capacity which is available on the system. And at that point of time, the other details are put into the system in the confirmatory note, and the timing and entry exit points and the pressure, redelivery points, the quality and other things, all those are defined, and how much volume is there, what is the rate at which it is to be redelivered, kind of things, what are the penalties, they are predefined already. So all these things are announced, and then that capacity gets booked on a daily basis, and that capacity then is not available on that particular day for the common carrier because it's booked. So all these are captured in a gas transportation agreement. The charges which are levied are upfront announced. In fact, in certain cases, the regulator, it's available on the portal of the regulator. In other cases, if it is a point-to-point pipeline, it is a dedicated pipeline where the tariffs are required to be negotiated between the two parties themselves, and there also they are announced, and they are pre-decided and known. And there are mechanisms for penalties, or if one or the other party doesn't act in the manner it is desired, or for them to act. And then, of course, all the other terms are standard as per any other agreement. The format of capacity tranche the shipper fills in, and that forms the basis of the delivery and redelivery of gas into the system and at the redelivery point. Quickly coming to pipeline tariffs, normally tariffs are defined in dollar per MMBTU. They are generally,
can I just make a small comment? How much time would you take? Can we just wrap it up in 5 minutes?
Yeah, I will just talk about tariffs in another 5 minutes, and then we'll wrap it up. And on transnational pipeline later, some other day we'll do it, or maybe later. Yeah.
Sure. We have quite a number of questions from the participants, and we would like to address them.
So quickly coming to the tariffs, discounted cash flow mechanism. I guess all the participants know very well, equating of inflows from the project revenue earnings out of natural gas pipeline. Inflows are equated with the outflows. Outflows come in form of capital and operating expenditures over the economic life of the project, and they are discounted by a reasonable rate of return. That determines what is the kind of tariff you should charge for those kind of volume flows to happen and to give you the kind of revenue stream over the lifetime of the project. So that determines what kind of a tariff is required to be charged. And incidentally, in countries like India, and I'm sure in other places, these are then given to the regulator. And the regulator then does an open house. People challenge, various kind of assumptions. And finally, the regulator, after hearing everyone, decides as to what is a good tariff. That is announced upfront and is then decided for long periods of time. In other cases, this is the basic model on which the basic tariff for a pipeline is decided. Now, there are variants of this. Once you decide as to what the pipeline tariff should be, how much tariff should be charged in terms of dollar per million BTU for the revenue stream to happen and for the rate of return to be available for a per entity which is constructing and laying a pipeline. Then you have models which are available as to how to charge this tariff. So there are postalized models for a pipeline. There are zonal tariff models for the same pipeline. Suppose it's a 1,000-kilometer pipeline, you could have a postalized tariff. You could have zonal tariffs. You could if there are several pipelines having different tariffs, each one will have a different tariff, of course, to recover the costs and get the rate of return that is desired. Then what happens is you are going from one pipeline to another to actually reach the end customer. Then you have to pay tariff 1 for pipeline 1, tariff 2 for pipeline 2, and tariff 3 for pipeline 3, and so on. Then those are add-on tariffs which somebody will be required to pay. Now, whether as opposed to that, whether it makes it viable or whether it makes it competitive for a shipper to transport that gas through that pipeline or use maybe a road route or some other route to reach the customer. So all that has to be seen. Then there are mechanisms like entry-exit system which are there. So you pay a toll for entry into a pipeline system, and then when you exit at a particular location, then you pay an exit tariff. So those mechanisms are also in place. Then there are telescopic kind of pipeline models where over a period of distance related tariffs are calculated and then decided. Of course, all that at the end of the day is based on the basic tariff for getting the rate of return that is determined. Then in India recently some of the pipelines have been announced based on a bid out tariff. So a regulator announces that a pipeline is required from place A to place B, and then each party who's interested in bidding and constructing and laying and operating that pipeline comes out and says, okay, I bid tariff X for this. The other party says, I bid X1, X2, X3. And then finally, the regulator, based on the competitive bidding that is done, decides as to which is the lowest tariff or the party which is most suited based on the tariff that they have bid to lay and operate that pipeline. And then those are bid out tariffs. So I will not go into detail. These tariff models, are postalized, which is a single tariff applicable over a pipeline, 1,000 kilometers or more. There are entry-exit tariffs. There are zonal tariffs. There are cost of service mechanism, unified tariffs, which is now being talked about. These are tariffs which are charged, as I said, 2, 3, 4 pipeline systems. Now, if it becomes uncompetitive, then maybe a united or unified tariff may be a better answer, which may be a weighted average of the tariffs of 2, 3 pipeline systems. Telescopic tariffs you have talked about. Bid out tariffs are another mechanism. Zonal tariffs are again, same tariff that we talked about, but these are based on every 200, 300 kilometers, a zone is defined, and then for that zone a particular tariff is decided, and that is leviable for any entry exit which is happening within that zone. If it is beyond that zone, then the tariff structure changes. In Europe, there are two mechanisms for tariff, which is one is a cost plus and a reasonable rate of return, and the other mechanism is an incentive mechanism where the revenues are preset and decided, and if investor or somebody who's laying a pipeline gets efficiency by laying a pipeline in lesser capex or operating it through lesser operating cost, then those efficiencies are allowed to be retained by the operator. So those are incentive mechanisms that come into play. In US also, there are several mechanisms: cost of service mechanism, negotiated rate mechanism, and then there is a market-based mechanism which two parties can negotiate between two of them. for delivery and redelivery of gas. So these are mechanisms which are prevalent across the world. Just to give you an illustration of one pipeline tariff which is in India, there is one pipeline going from east coast to west coast. It is east-west pipeline. It is known as east-west pipeline, over 1,000 kilometers long, and it has been divided into 4 or 5 tariff zones. And for each zone, there is a different tariff. I mean, these are illustrative numbers. Say, for example, for zone 1, which is first 200 kilometers, the tariff is just 20 cents or thereabouts. Then if you go to zone 2, the tariff becomes 60, 70 cents kind of a number. And then if you go to zone 3, it becomes 80 cents. Zone 4 may have 90 and zone 5 may be higher. So if you take a weighted average of the customers in each zone, the amount of gas which, for example, entry happens at this location called Kakinada and gets, exit is in zone 1, 2, 3, 4, depending on how many customers are there. The weighted average may come to maybe 80, 90 cents kind of a number for the entire pipeline. And then this is reviewed every 5 years or 10 years, depending on the kind of regulations that are in place, to see whether the pipeline gets the desired reasonable rate of return, or if because of some new capex which has come in, or because of lower flows which have happened over a period of time, whether the rate of return is adequate or not for the pipeline operator. And then the tariffs get revised after due diligence and open house and things like that. I think I will stop here, sir, and for cross-border transnational pipelines we will have another 15 minutes some other time. Thank you very much for your patient hearing.
Thank you very much, Rajiv. Thank you very much, Rajiv sir. So we would like to quickly move on to the question answer session. We have quite a number of questions from OGRA, which is the regulator of gas sector in Pakistan. The question is, what is the status of converting gas into hydrogen and adding to the pipeline, specifically using stranded fields or flare gas in world, and especially in India?
So hydrogen is something, although it has been there, talked about for a long time, we are still in discussion mode, and no pipeline today has blended hydrogen being transported through the pipeline network. Balyan Saab, would you like to add?
Yeah, the only initiative that is being taken very recently is for the Delhi Transport Corporation, that blending of hydrogen with the CNG there, which is recently started. So that's the only major pilot that has been commissioned and is operating. Don't know as the result, but they are expected to be making this thing. But as a pipeline supply, no supply as such. There is a hydrogen capacity which mixes hydrogen into the gas, and that is used as a fuel now.
Okay, thank you. Question is from Ziauddin Ogra. Are merchant terminals in India exempted from the third-party access? If yes, on what grounds?
Well, I'll come to that perhaps in the next regulatory thing, where and we'll deal with this appropriately. We'll talk about this.
Okay. Another question is from Shaheen from Ogra. How many transmission and distribution companies are in India, and do they have separate network for their customers?
So there are many transmission and distribution companies now in India. Distribution companies are maybe dozens of them, but transmission companies are at least 4 or 5 are major companies, and then there may be smaller companies also doing transmission, And the regulations are applicable to all of them for open access, common carrier capacity, etc.
Is gas pipeline tariff regulated or negotiated between the parties? What is the gas pipeline tariff mechanism in India? Any illustration, example? Also, what is the rate of return for pipelines used as common carrier? Altaf from Ogra.
So for a dedicated pipeline between point to point between supply source and a single customer. It is negotiated between the two parties and decided, agreed, and put in the transmission agreement. For common carrier pipelines which feed more than one customer, for legacy pipelines which came before 2006, the regulator, after hearing everyone, looking at the capex, opex, etc., decides what the tariff should be charged, and then that is reviewed over a period of time, as I said. For new pipelines which came after 2006, which are bid out, the bidding itself decides as to what the tariff would be over 25-year period or whatever the bid out time is decided, and then one has to live with that bid out tariff. Once you get the authorization for laying and operating that pipeline. And I gave an illustration of one pipeline kind of tariff numbers that are there, on zonal basis. But tariff could vary between 5 cents to maybe $1, $1.50 kind of a thing.
Thank you. Another question is from Ms. Misbah from Ogra. How maximum pipeline capacity utilization is ensured and its impact on the transportation tariff?
So for existing pipelines, the capacity utilization is maybe around 60-65%. And as new markets open up, new capacities get added, and new compression capacity creates more transmission capacity, the utilization level is coming down to 50-55% for existing pipeline networks. For new pipeline networks, they are, as I said, they are all bid out. The risk of market being there and the assumption of how the tariff is decided and bid out is squarely on the shoulders of the bidder. And therefore, for other pipelines, the regulator says it's around 65, 70, and 75% in the first 3 years. Those are the assumptions they have taken. But then for bid out pipelines, the bidder has to take a call on what kind of capacity or gas flow would happen. Based on that, they have to determine what the tariffs would be and then bid it out. And if the flow is not commensurate, then they run the risk of not getting the reasonable rate of return which they were expecting.
Yes. Question is from Sajid Ali. Developing gas storages in depleted gas field. Would it be cost effective while knowing that not all gas could be recovered and considering other associate operational requirements?
So gas storage, definitely it is a costly affair. One has to look at the market conditions, the seasonal variations, the peak requirements, and the cost associated with storing, and whether it is worthwhile doing it, or use the long distance pipeline themselves as storages, which we have been doing in India for a long time. But then it's a call which each one has to take.
Okay. We have a question from Pakistan. Yes, please.
We haven't used a depleted field as yet for the storage as such. And there were some studies to look at appropriate caverns, salt caverns and all. But we haven't really started using as a practice in India.
Another question is from Pakistan LNG Limited. Why pipeline operators developers are tagged as monopoly? Pipelines are capital intensive projects and other players just want to utilize the infrastructure on short-term basis, sometime by supplying the gas to existing customer of pipeline operator.
So it is not for me to say why they are treated as monopoly, but they have been defined as monopolies because from point X to point Y or market or the supply source to the end market, once a pipeline is laid, generally nobody in competition would lay a parallel pipeline serving the same markets and trying to compete with one pipeline operator. unless the capacities are utilized to the optimal level. And if there is no competition, then acting as a monopoly, the thought is that the pipeline operator could dictate their own terms for shipping and supplying volumes from the supply source to the marketplace. And because of that, there is an empire which is required in form of either a regulator or government or anybody else to ensure that anybody who wants access is given that opportunity. And if it is not, then the end customers or the markets have to be at the vagaries of whosoever is getting the LNG, whosoever is gasifying it, whosoever is supplying it. And if they find it competitive enough, they will take that, otherwise they will not. Yeah.
I would just like to add a very small comment to this, because the concept of calling the interstate pipelines as monopolies, this came long back in the United States of America when they were laying. This was in 20s and 30s, 1920s and 1930s. And then just because these interstate pipelines, they were charging a lot of high prices, the regulations came in, and we'll be dealing all this in the coming session. But the very fact that they are very capital intensive projects, laying interstate or large pipelines, and no other pipeline is allowed to come, so they are given that exclusivity, and that is why for that exclusivity they are called monopolies.
Okay. We have a question from Altaf from Agra. What is the rate of return for pipeline used as common carrier? Any reasonable rate of return for those gas pipelines?
I guess a bidder would be looking at maybe somewhere around 12% or so, but then it has, because once you are bidding, then you have to take a call as to what is the reasonable rate at which you get equity or debt, what is the kind of margins you expect, and what is the reasonable return that you expect.
Okay, thank you. So we'll just take
I'll just like to add that in India, the regulator goes in the gas sector, the regulator goes in for an IRR. And this IRR is somewhere between 12 to 14%. But in India, for the power sector, the regulator goes in for return on equity. So that is a difference between the gas sector and there, because the sector is not developed. Because when these regulations were being made, and we argued with the regulator that we already have regulations in the power sector where it is return on equity which is being offered as the incentive to the developer. Well, the regulator was, generous enough to say that we have to go on IRR model because we have to develop the sector, we have to develop the lines, pipeline network, and that's why in India we have gone for the IRR as in many other countries where pipelines have been laid.
Okay, so we'll just take one last question, which is from Rashidul Hassan. He has not mentioned his country. May we create an energy hub inside SAARC region countries? Will it be useful?
So I guess we have a session on hub tomorrow. We can.
We have a session on this
tomorrow morning. I think
we'll take it up then.
Yes, we can.
That's one of the objectives. One of the objectives of regional cooperation.
Yes, so I think we are over with the questions up till now. So we'll just quickly move on to our next presentation, which is the last presentation for today's overall schedule. My apologies to the participant, but we had to cover all these aspects of LNG in a one day, and that's why we had to extend our timeline for the today's schedule. So the last presentation will be on the regulations and the policies in gas sector. The contents include role of regulations policies in upstream, midstream and downstream, illustration of regulatory mechanism in the gas sector. The presentation shall be delivered by Dr. A.K. Balian, and I would request Dr. Balian to start his presentation
now. I have to share my.
Okay. Can you give thanks?
Can you see this thing?
Yeah, we can see it, sir.
Yes.
You can.
You can start, sir.
Yeah, thank you very much, and hearty welcome again to all the participants and delegates. And thank you the SAARC Energy Center, Dr. Nawaz and Ehsan Saab for professionally organizing this training program. I would be talking on the regulatory framework that exists. A particular focus would be on the SAARC countries, and some of the good initiatives that are there can be taken as a good examples to learn how the countries themselves have evolved and what is the status right now on that. We'll talk about the government support, also the regulations in Pakistan and India, and particularly touching the LNG business particularly. A little bit on the historic background, we must keep in mind that how the SAARC countries have evolved. We all had international oil companies operating in this region, and there was a wave of sort of nationalization, and this was in line with the political thinking that time to have little socialistic approach, and therefore the all major international companies were nationalized, and national companies came into fore in all the important sectors of the industry, whether it was oil and gas or steel or power. We saw the emergence of the national companies which took center stage for development. In Nepal, Nepal Oil Corporation came. In Sri Lanka, the Septco came in there in different years of that. After this nationalization, all the growth were driven by the government countries and supported by the government. Over the period of time, it was then sort of a learning that the approach, working performance of these companies were not really that satisfactory, as normally the government companies who work on cost plus system, the targets and all were different, not really that little extended target. So the performance came into this thing, and government decided that continuing with the same system may not be really efficient, and they need to really bring in competition and particularly look at the regulations there and make the sectors open up, deregulate them. And this policy might support bringing in new players, the private sector within the country, as also foreign players, which can bring in perhaps new technologies, new way of working, and that's what has been followed in these countries. Legislations were introduced, and at the same time, it was also thought there has to be perhaps a place for regulators to overview. And the relationship with the regulators and the government was that regulators must work at an arm's length distance. For any country, it's very important that the government need to really recognize that without their support, without their initiative, there cannot be any development. So the important areas where we feel that government support has to be there is, number one, to create maximum value of hydrocarbon resources. Governments are expected to create that legal and fiscal framework in the country that is enabling and sort of moving towards liberal market scenario to promote investments and developing of the oil and gas and LNG and similar kind of investment and projects. It needs to be equitable. The rules, regulations must be equitable so that they are followed by all, just not by the government companies, but private sector as well. And they should be in line with the aspirations of the market. Also, that it was felt that a PPP model would be a better model, where the public-private participation is encouraged. Formulate long-term policies, and have the private participation in all kinds of projects more viable, and it was thought this needs to be promoted. A very stable and sustainable business environment is very important, where the rules regulations are not changed suddenly, and you create a very stable, viable, transparent investment climate where all other stakeholders can come in, whether it's investors, financiers, the companies, the developers. They all can perhaps look at a very stable, growing, enabling environment. Simple administrative working is very important. I mean, it's simple is always good. So you can really understand this thing. If you have complex rules, complex regulations and procedures, which even the interpretation of some of the regulations and rules becomes very difficult. So it is important that you have simple rules working, and that is perhaps is what is desired. And then create an independent regulator. The emphasis I'll put is on independent regulator, which works at an arm's length relationship principle with government and is not seen as a government actually. Otherwise, there won't be any difference. And then the regulator for all very clear, distinct arms of the sector, like in oil and gas sector, it is upstream, midstream, and downstream sector. So a separate regulator for that. When we come to a role of regulator, it is to really overview, oversee, supervise, monitor, and also advise the government on various kinds of project stages. How do you really implement it, get approvals of that? And one of the key roles would be to really monitor the industry players, setting the tariffs across the value chain, periodical review, involving experts, industry consultations who can really advise, who have experience in dealing with such matters on that, setting and collection of taxes, fees, clear, consistent approach, and not just being arbitrary and random in your decisions on that. Clarity on role, as I said, it's important that you have regulator for upstream, midstream, downstream, and power. We have examples in India that we have the regulators for that. We also have regulator for safety, which gives rise Oil Industry Safety Directorate, which of course works as one of the separate division within the ministry, but is specialized on the safety regulations of the country on the hydrocarbon sector. Director General of Mine Safety really looks after is the regulator in the mining operations, and upstream drilling activities, exploration activities also come under this. There is a specialized organization which supports such activities, the regulator, the PSU, which provides operational technical advice, approvals under the Explosive Act, which is pretty old and is still very, very relevant. And they give advice on manufacture, import, export, transport, possession, sale, or use of explosives, petroleum products, and compressed gases. Here it's very important that even, for example, storage of gas or a storage of petro products, what kind of storage, their specifications, their standards need to be approved by PSO. Same is for LNG. LNG storage also need to be, or even a truck, for example, LNG on wheels, as we talked about, that also need to be approved by PSO. So overall, if you look, the regulator has a vast scope on, for example, city and local natural gas distribution networks, natural gas pipelines, petroleum products pipelines, gas, LNG, and petroleum products storage and transportation, gas exchanges, and technical standards finalization and specification finalization for all safety standards for oil, gas, petrochemical plants, equipment, testing, and measurements. So a very wide scope, and they have a very important role to play. And therefore, it's very important to have a good regulator, and I say good, which is proactive, which looks how you can provide growth to the industry at the same time, works not as a government but as a promoter, as a facilitator for developing the sector. I'm not able to move ahead on my slide.
Shall I open the presentation, sir?
Sir, can you just click on the presentation?
Okay,
Click on the
yeah, I
presentation,
think maybe,
sir.
I think, yeah, okay, sorry, yeah, that was my mistake, yeah. So let's talk about the upstream policies and regulations in the SAARC region, the upstream. So as all the countries in this region have experienced that either the hydrocarbon resources are less, not really, we are abundant availability of hydrocarbon resources. Also, whatever production levels were there, they started declining over a period of time, and new areas for exploration were really looked and were made available for that. But those areas were very challenging geologically as also technically difficult areas. So this required new technologies. There were also mounting subsidies, heavy import bills on more imports. All that meant that there has to be a relook at the policies. Policy was, in the countries also there was slight difference in the legislation and also some of the conditions in terms of cost recovery, profit petroleum, revenue sharing, price benchmarks. There's a slight variation on that. For example, India shifted from initial stage of giving blocks areas for exploration and production on nomination basis to a bidding of the block situation. Then came the new exploration licensing policy, which was more competitive and opened up for players from other private players, also players from the foreign countries also. And now we have shifted to an open acreage licensing policy, which is a real-time exploration. Any company can, without any periodic bidding or so, they can come up any time of the calendar year and seek permission to explore in particular area. Pakistan led the revival by offering very attractive terms actually and conditions for deep offshore and marginal fields from 2012 onwards, and all the countries created a system where exhaustive geological information was made available to potential bidders, so that they are well prepared and are more comfortable to make a bid, and the access was provided to all kinds of geological data to them. Like in India, we have a regulator, we call it Director General of Hydrocarbons, DGH. Pakistan has DGP, PC. Bangladesh has come up with the BERC as a regulator, which also sees hydrocarbon besides the power. But Petrobangla is the main company, the government company, which also helps government to make the regulations of that. Sri Lanka has Petroleum Development Authority there, and also which was earlier known as PRDS, and now being sort of with a new avatar. They are there with more empowerment and roles. Midstream and downstream policies, if we see on this in this region, there is again a proactive approach we are seeing for the governments to open up the sector and move towards market-driven scenario and provide more competitive environment and for inviting more investments, private sector. Focus is definitely on creating that infrastructure, robust infrastructure in the country, and also to integrate in a mapped way with the international market. That's no other option but to do that. So we have the regulators in the SAARC region. In Pakistan, we have the OGRA, which was created 2002 through the ordinance, and now perhaps Pakistan is looking at creating a tribunal. This is a natural way of moving ahead in the same direction. As to if there are issues, there has to be a mechanism to deal with the disputes, and also a tribunal is being thought about. In India, we have the PNGRB, Petroleum and Natural Gas Regulatory Board. We also have, which was created in 2006. We also have a Petroleum Planning and Analysis Cell, which provides and keeps all the data. It's a central data repository with the government. Is a separate cell on that, and this makes the basis for advising this thing. We already have a tribunal in India functioning. Bangladesh has a BERC now, which was created in 2003 through a resolution, largely looking after electricity, but also for gas and petroleum products as well. Sri Lanka has a Public Utility Commission of Sri Lanka, PUCSL, created in 2002, which looks after the economic, technical, and safety regulator as a regulator of electricity, and also is a designated regulator for petroleum and water services industries there. Very unique, actually. Nepal has oil and gas activities under the Nepal Petroleum Act 2040. This is the number, which was created in 1983. And later on, they modified with amendments the Petroleum Regulations 2041, which was done in 1985 as a guiding principle for the country. Bhutan has Bhutan Electricity Authority, which regulates hydropower. And they also have the National Environment Commission, NEC, which monitors the environment impact development. But the Ministry of Economic Affairs is the overall umbrella organization to regulate all the energy related aspects in that. Afghanistan has the Afghanistan Petroleum Authority 2013, and also a regulatory authority, AOGRA, which looks after the project management, governance, regulation, and supervision of oil and gas sector. Maldives also has a Maldives Energy Authority, which comes under Ministry of Housing and Environment, a very unique way, but then they also are responsible for overall energy management and regulation in the country. So it's heartening to see that all the countries under SAARC have a mechanism to really regulate and work and see the hydrocarbon sector, the energy sector. What would be the main guiding approach for regulations and policies? And it's very important, as I say, that we need to have a regulator which functions as an advisor to the government, also proposes or develops and documents and notifies the regulations for the sector. So there has to be definitely a very fair and transparent way of working. So and that too, to create what we call it a level playing field. All players on the same level as far as the rules, regulations are concerned, benefits are concerned, or restrictions are concerned. Also, the very second important point is that all the regulations and policies must be directed to protect the consumer interest. That should be the focus point of that. Number three, they need to be investor friendly. Otherwise, there would be a sort of a bar on further investment. So how do you really make your policies and regulations to help more investments? Must nurture the growth of the sector, and at the same time also monitor, audit the performance and the implementation of the projects in the sector. So very clearly, the guiding principles are very clear on this. We also must see that while we are formulating our laws, there are certain things that have already been experienced, in other countries. So we need not rediscover the wheel. We can really learn from that. And one of the markets, the three major markets, I would say, is the Europe, the British particularly on that, and the Spain did a lot of work on the gas. They have a good regulatory mechanism which has evolved over the last 10 years time. So one of the learnings we took a few things from the US gas industry, which is one of the most matured gas market of more than a century old. The market is surplus with pricing freedom for producers, a business model for pipeline transportation, a free market for gas distribution, ideal for any mature gas market. If you see from the legacy of policies, acts, regulations that provided, that gives us a sense of this thing, how the market has moved up. If you see, three major acts would really clarify how the US market has moved. The first one was the National Gas Act, NGA, in 1938. And this was a move in US to really regulate the market. They said, and they felt that there is a necessity to regulate the market, so they brought in that regulation. Then late, after more than 50 years, 40 years, they came with the National Gas Policy Act, NGPA, which actually gave direction that, oh, so many regulations are not required. You need to deregulate and create more this thing. And the same trend came the Natural Gas Wellhead Decontrol Act 1989. Very briefly, we'll see this. So this NGA 1938 towards regulation was a federal power commission. Actually, they sort of pushed it. The key objective was to arrest the monopolistic business practices of the pipelines. So it came in the 1954, the major decision, which is known as the Phillips decision of the Supreme Court, brought the pricing of the national gas producer under regulatory oversight of the Federal Power Commission on this. After some time, they started what the impact of the Phillips decision was felt, which allowed the producer to sell gas to market prices within the state, but discouraged interstate sales. Now, this created a distortion and a shortage of gas, in spite of the efforts by the Federal Power Commission to deregulate, but it brought in another problem there, and therefore there was a need to really relook into this, and the National Gas Policy Act 1978 was brought in, which was a step towards deregulation. So the key objective was to break down the barriers between intrastate and interstate and develop a single gas market in the country. Also to allow market forces to establish wellhead prices. And in 1978, the FERC order 436, generally known as Open Access Order, was brought in. And this Open Access Order is, I think, was then later on discussed and adopted in many ways world over in many countries on this. The market gradually turned surplus, and FERC Order 500 allowed take or pay on pipeline owners to be passed on. So this again a new thing that has come up, that we now using it. It was actually practiced already in the US. In the Act NGPA 1989, the NGPA was amended. The earlier this thing was amended, and a complete deregulation of wellhead pricing was made. And the FERC Order A636 1992 separated. This is again a very important thing, which many of our countries and SAARC countries are also struggling to do, that is to decouple, unbundle it, separated the transportation and sales marketing functions into two different areas on this. And so I think there are several learnings which we can really take directly from some of the very matured markets in this. So the main takeaways from this thing would be the above, illustrate how the tight regulations can impact the growth of the upstream, midstream, and downstream. And this is learning for the regulator, that how things have happened and how they brought in new regulations to really unlock that. And how do you create a balance between the legislation, the regulations, rules, and the judiciary? And each played an important role to really create a very matured, open, liberal market which is thriving. If you see in Pakistan, actually we do not have much information on that, but the main function of this OGRA includes formulation of regulations and the supporting rules for LNG business. Processing of application of LNG developers for LNG terminal to construct and operate energy receiving terminals. The OGRA came up with their regulations in 2007 on the processing of licenses for transportation, filling, marketing, and distribution of LNG. Obligations of the LNG terminal owners, operators, very specific on LNG actually. Modifications, extension, revocation, and renewal of the licenses, inspection and audit of the LNG terminal, and also dealt under the said rules. I think OGRA is an exemplary role they have played very proactively along with the government to really create a very thriving, good LNG business model, and which has helped construction and operation of the terminal in Pakistan. It's a good success story. the same as the recent notification we see is that the LNG terminal and storage access code 2021 is being done. We would be really welcoming some more details if they can put on their website. Coming to India, one of the few countries in the SAARC which has perhaps more experience with this, the regulator actually has a key role to regulate in the activities of refining, storage, transportation, distribution, marketing and sale of petroleum products, natural gas, and city gas distribution. Is very active in this last area of sale of petroleum products, natural gas, and city gas distribution. The various functions of the board, we call it Petroleum and Natural Gas Regulatory Board, PNGRB in India, they look after protect the interest of the consumers by fostering fair trade and competition, registering of the entities, I'm very important here, registering the entries of market notified petroleum products, natural gas, and other contractual obligations of the central government, and establish and operate LNG terminal. We'll come to this detail on that, what is the registration being done. They also have the responsibility to authorize entities to lay, build, operate, and expand common carriers. You would have seen the pipeline what Mr. Rajiv Mathur talked about in India are under those rules, regulations. Lay, build, operate, expand city or local natural gas distribution network. Declare a pipeline as a common carrier or as a contract carrier. And other important functions is to fix transportation rate for common and contract carriers, define pipeline access code, define safety standard, and define affiliate code of conduct, that is for arm's length relationship where there is of interest. The key regulations which have been notified by the regulator in India for gas pipelines are the authorization for laying, building, operating, or expanding natural gas pipelines. Proposals for new pipelines can originate from any interested entity through an expression of interest, but then PNGRB really overtakes it and processes through a very transparent process of this. The network access code, main objective of this regulation to ensure the gas supply to any place from any place at any competitive cost on a non-descriptive basis. No description, level playing field for all players on this. Affiliate code of conduct for entities engaged in marketing, where there could be a possibility of conflict of interest. They define the boundaries as to how decisions should be taken. Although in India, we are still not having the unbundling process executed or implemented in the country. But then I think the regulator has brought in a fair amount of transparency in this field. Determination of tariff for natural gas pipelines. We've already discussed this on a very fair basis. And declaration of natural gas pipeline as common carrier and contract carrier. We will discuss on this thing. And determination of capacity of petroleum products, and natural gas pipelines. This is very important, and this is a parameter which need to be constantly monitored. And they declare their pipeline capacity in million standard cubic meters. For natural gas, capacity determination is based on very approved, selected package of flow equations in a very transparent way. Again, anybody can really get an access and ask for detailing of this. Some of the regulations that have been notified by PNGRB in India is the determination of network tariff in 2008, exclusivity of city gas and local gas distribution, authorizing entity to lay pipe in 2008, technical standards specification including safety for city gas network in 2008, regulation of quality of service 2008, regulation of access code for city gas distribution 2011, regulations of integrity management system of city gas distribution, local gas distribution in 2013, and also determining the capacity of local gas distribution or particular capacity of pipeline in 2015. So several notifications are being issued by the board, regulatory board, from time to time. One of the interesting case study, I thought that how a proactive regulator can really make an impact on the growth of the sector. City gas distribution we have seen, and India has gone up to 10 rounds of city gas distribution, where different, what we call it, geographical areas, where the gas has a demand. Those areas are called and they're sort of made in a compact area packet, which is known as geographical areas. We have gone through the 10 bidding round on that, and we are all set for the 11th round now. But we see, as you see this thing, how come the 10th round was so successful? We analyzed that what all was different. So, to my understanding, there are the points that the terms and conditions for bidding were made very clear, and there were a lot of several rounds of the all potential bidders, investors in this, and the terms and conditions were firmed up, and they were made very clear. They made a special this thing that made eligibility criteria more stringent. And the purpose was that only serious bidders and quality bidders come in, not just for the sake of some other bidders come in there. So I think they made the eligibility criteria more stringent, and that has helped actually that really good bidders, serious bidders came into this. There was always a confusion about the charge area. Charge area is the area within the geographical area where the supply is concentrated, and the bidder is to really focus on this, developing this area for gas supply. So the optimization of charge area and geographical area was done in a way that the geographical area were larger areas for economy of scale, and charge area was not distributed, it was more concentrated. So the bidders were, but for them it is easier to focus on that, develop that. Also a restrictive condition on that the bidder should be able to tie up the gas supply within 180 days of the award of the geographical area was done away with that. And this proved to be one of the very important removal of a restrictive conditions. And lastly, larger in the economy scale, large districts areas were offered, 260. So there were number of players were very large, and we saw that all this regulator worked in terms of how to make it successful, how to make it happen, and give a growth impetus to the city gas distribution. This is one of the examples I thought I will share as a success story in India. Coming to specifically LNG business, the LNG business in India is growing around 4% annually, and slowly we feel that all those parameters that are required are important for a mature gas are there, but then perhaps they need to grow more, but we are slowly moving in the direction. We can say that the LNG business in India is largely unregulated. There is hardly any specific regulation that is in place as of now today. Anybody can construct an LNG receiving terminal. The only regulation issued by the Petroleum and Natural Gas Board gives the freedom to establish LNG, RNG dispensing unit to anybody irrespective of the CAG. So this is a new thing that they have issued, is that although in the city gas distribution, a particular company A has been awarded as this geographical area, but any other company can establish a LNG satellite dispensing unit in any of the GA. Even if they have not won the geographical area, they have the liberty to construct a satellite. This is again a kind of very liberalized view that the PNGRB has taken. Right now, the PNGRB is engaged in an industry consultation process for a process we are calling a registration of the LNG terminal operators in the country. And I think in the so far we feel that some of the good practices from the other mature markets in terms of third-party access, tolling, capacity booking, user pay provisions, competitive regas charges, and all have been sort of assimilated by the regulator, and perhaps taken a larger view. No such new regulations so far have been issued, but then it's taken a very liberalized view towards the LNG business in this. However, for construction of the terminal facilities, we are required to follow a very proven technical standard, which could be a European standard, a US standard, or a Japanese standard, and all the prevailing latest guidelines and the international standards with respect to marine operations or infrastructure are being followed. And we see that the acceptability of this business in India is that practically you see from all parts of the world, the LNG producers are there. They have supplied their LNG. They brought in their ships here in India. Some of the other regulation with respect to the LNG business that have been sort of brought in are here in the Schedule 1, which has all the technical features. So for a construction of terminal, they are the recommendation in the Schedule 1, A, B, C, D, E, F, list down the design layout of the facility, electrical system, process system, maintenance and inspection schedules, competency assurance and assessment, fire prevention system, safety management system. All these standards are included in the schedule, and which has been sort of recommended by the board and informed in 2018 itself, and they are available. These are being followed by all the builders of the terminals in the country. Now, for the registration, right now, as I said, the board is trying to register and create a process of really having a very healthy kind of cooperation and relationship with all the LNG business stakeholders here. So they've said that the registration process requires that the terminal should either comply, declare, or report following aspects. Number one, they have to comply with all the technical safety standards laid down by the PNGR, and they are only just limited, as I said, in Schedule 1. And they are based on all very standard, construction and technical standards, safety standards taken from the world standards. They need to also declare what are the entry and exit point wise design of the plant, available capacity over and above its committed capacity for receiving, storing, regas, and transporting the regasified LNG. And this is for the purpose of to share that over and above uncommitted capacity for use to other entities without any discrimination. Also undertakes safety audits during construction, commissioning, and operation phase ordered by the board, and shall host above information on its website every quarter. They would also inform any change in ownership, composition of the board, modification, addition of facilities at least 3 months in advance. So these are the proposals in the registration, where once they are registered, they will have to follow this. So far, the registration is under discussion with all stakeholders. Then the developer shall furnish a performance bond of rupees 10 million, guaranteeing timely commissioning and meeting of the service obligations of this. This is also proposed. Based on this, the PNGRB shall issue a certificate of registration, which will be valid for 25 years. And after the completion of 25 years, a further extension of 10 years can be granted based on the inspection and other things. The board can also cancel the registration if the developer fails to meet the milestones of the RFR in the construction phase, or fails to observe and comply with the conditions, service obligations, technical and safety standards of the plant. The certificate also cannot be assigned, transferred for sale, mortgage, leased, or exchange without prior approval of the board. So these are the salient features of the registration which is being proposed, for which the board is under sort of discussion with the industry, with experts, with all the operators which are right now, and all other which are potential operators in the country. What are other important things that are happening and which the regulator board is looking at? We discussed briefly about, Rajiv mentioned about the unified gas transportation tariff. Now the regulator is looking at that for a nation. We are sort of looking at one nation, one gas grid. And that is only possible that if we have a different gas transportation tariff system which is applicable and acceptable to all the players, stakeholders of this thing. So the unified gas transportation tariff is defined as the weighted average of approved zonal tariff in respect of the pipeline formatting part of a national grid system, which Rajiv also talked about this. So this is a proposal which is again under discussion with all stakeholders in the country, and there are many other movements which are moving towards one nation, one gas grid thing. And the other is, to my mind, another development has been the operation of a gas exchange in the country. Now, this gas exchange operations has been approved by the board very recently, a few months back, and the gas exchange has met the preliminary basic requirements of the board in terms of creating that transparency and timelines and procedure systems that are required by the board. So there is a contracting hub, trading hub, which is done by a separate operator, and then there is the transportation aspect would be taken up by a separate transmission system operator, TSOs as they call it. And they are going to work as arm's length distances. A buyer may not know who is the seller of the gas. And then they have a liberty of a day's trade or a weekly or monthly, and also all that kind of a transparency that are required in a hub which fulfills the requirement of a board is very much there, and the exchange has started operating. We see for several months it is doing well, and the trade amount, although it is small, and it is the sites are different, close to different terminals, LNG terminals, but then the trade is growing. And we also see that slowly the West India LNG price is now being quoted by several benchmark operators that they give the estimates of their pricing in different parts of the world. These are the developments that we have seen very recently. I think I'll stop here, and thank you very much for your patience hearing. We'll be happy to take few questions if there. Thank you.
Thank you very much, Dr. Balyan, for this detailed presentation. So, ladies and gentlemen, we would quickly move on to the question answer session. We have a question from Shanita Safwat from Bangladesh Petro Bangla. Does regulatory framework should differ significantly between government company and public investor? If so, how?
Can you repeat, please, Dr. Hassan?
Yes. Does regulatory framework should differ significantly between the government company and public investor?
No, I think that's why I said the underlining requirement and basic principle of a regulator is that he does not distinguish between any entity, whether it is private, joint venture, or a government, or a foreign, or a national thing. It creates rules, regulation at a level playing field for every player in the sector.
Okay. We have a question from Ogra.
Dr. Hassan, I'll just like to add that what
Sure,
the regulator can do, that in case a new regulation comes in, which would also have private players and government players, and there already are government players nominated on nomination basis already in the domain, then probably the regulator can take a call that these nominated players can now get registered and on a suo motu basis, and that would be accepted by them. So that has been done when the new regulations came in, and there were already many pipelines owned by the government companies or government-owned companies in operation.
So another question is from Mohammad Junaid from Agra, Pakistan. Commercial and safety goes together. How PISO and PNGRB coordinate on the safety?
So there are two different sort of scope of work. While the regulator gives the guideline that you follow this thing, and these are the standards that you need to follow, PESO is the organization which actually certifies that. The designs, the engineering, the construction, everything, the process to be followed as per that particular standard is there or not is certified by PESO. So once the PESO has certified, there is no problem in going ahead with the project. So their scopes are different and very clear in their domain of work.
We have a question from Shaheen Ogra. What are some of the softwares used for pipeline capacity calculation?
Well, Rajiv, can you take up?
I think maybe we'll separately, get those details and pass it on to you.
Okay.
Pipeline Studio is very commonly used, but yes, specifically what is being used would have to be found out.
I mean, there are lots of softwares being used, but I can get you the details of what is prevalent today.
Okay, perfect. So maybe we can share the details in tomorrow's session. Another question is from Rashidul Hassan. I think he's repeating the same question. He's from RPGCL Bangladesh. May we create an energy hub inside SAARC region countries? Will it be helpful? So we have earlier mentioned that we have a separate section on this topic tomorrow at 11:15 on the intra-regional trades and the gas hub. So we will definitely address that issue in the tomorrow's session. So we can also address your question in tomorrow's session. I would repeat again to the participant that if somehow I can see some of the participants have already left, those who have asked the question. So the recordings of all these training sessions will be available on our website after the conclusion of the training tomorrow evening. All the recordings will be available on the YouTube channel also and will be shared with you. So if anybody has somehow missed any session, we can definitely attend it privately later on. Plus the presentations shall be shared with the participants at the end of each day. We have already uploaded the presentation up till day 3, so day 4 presentation will be shared. And I think we are over with the today's session, and all the questions have been addressed. If somehow somebody else, some other questions are remaining, we will address them in tomorrow's session. We have specifically kept half an hour section for the wrap-up open house for participants with lead trainer and co-trainer sessions for tomorrow. Before the end of tomorrow's session, so we can definitely address those issues or questions which are left over, and participants can ask those questions in tomorrow's session. So I think we would close this session for today. We are very thankful to Dr. Balian for an excellent presentation on the regulatory framework, and the other presenters who had presented in the morning. Thank you very much again, and have a nice day.
Thank you.
Tomorrow again at 10 a.m. Through the same web link, we will connect. Thank you very much, Dr. Balian.
Thank you very much, sir. Thank you very much. Thank you very much.
Thank you.
Thank you, Hassanji and SAARC Energy Center. Thank you.
Thank you very much.